Good morning, everyone.
Mhm.
I believe we are ready to start. Can you hear me?
Yes.
Okay. So after yesterday was a successful day, we will continue today with the second day of the web conference, Climate Change and Blue Growth, New Perspectives and Trends. We have 4 sessions in this day, and we will start with a session, Spatial Analysis and Remote Sensing, presented by Professor Kostas Poirazidis and Haris Dimitriadis from the Department of Environment in Zakynthos and the National Marine Park of Zakynthos, with the title Mapping of the Offshore Stress and Risk Factors for Sea Turtles at Central Mediterranean. Professor Poirazidis, please share your screen. Just to set some ground rules, please keep your microphones muted during the presentations, and if you have questions for the presenters, please write them in the chat area. Thank you.
Thank you. Thank you, Stelios. Welcome to all of you. Good morning.
Good morning. Good morning to all of you.
Stelios, can you see my presentation?
Yes, yes.
Okay. So just to hear, me and Haris Dimitriadis will present you a deliverable of a BlueCoast named Mapping of the Offshore Stress and Risk Factor of Sea Turtles at the Mediterranean. Just an introduction, human use and natural pressures do not act in isolation, but rather interact in a complex way, leading to additive, synergistic, or antagonistic impact upon marine biodiversity. So, cumulative vulnerability assessment lay in the identification, mapping, and quantification and synthesis of multiply pressures that recognize to have an impact or to select the future of the ecosystem. So the utility of risk and vulnerability assessment is acknowledged at the highest political level as a valuable tool providing guidance to marine managers and assist maritime spatial planning and adaptation to climatic change. Let's say to what is mean vulnerability is the potential for the sea turtles to be harmed and the result of the exposure to threats, sensitivity to these threats, and the ability to adapt to changing conditions created by these threats. So during this BlueCoast deliverables, we attempt to assess the risks and threats posed upon sea turtles in the marine realm. We try to estimate the sensitivity to each threats and ultimate estimate, and finally to map the vulnerability across the Ionian Sea and the South Adriatic Sea as a spatial explicit conservation and management tool. The base idea lays beneath the general concept of risk assessment, or let's say vulnerability, for the sea turtles under the effect of human pressures and climate change. So what we use, also some of the variables also they presented yesterday, the variables, what we have so far. So that the value we used is the abiotic climatic change. One presentation of this also will present in the next presentations, mean chlorophyll concentration per cell, sea surface temperature variability, nesting beach retreat modeling, vulnerability of nesting beach to sea level rise per cell represented by University of Athens. Also, we're looking for the sea turtles, like migration corridors, habitat usage, importance, the foraging habitat usage and nesting habitat. This study was presented by University of Thessaloniki. And what we present in this presentation is the the human pressures on this vulnerability. So far, we estimate the density of marine traffic. We'll discuss in details later. Regarding 8 vessel types, the first 7 is presented here, and also for the fishery densities. Also, we are looking for the zone of influence of port effect on the sea turtle, the influence of land-based pressure like urban and road coverage around the nesting beaches, and pollution from floating plastic in the sea. To see this analytical, at first, the base analysis scale for this vulnerability assessment was based on a European grid of 10 kilometers. We decided to follow this European analysis grid, so that later comparative analysis can be made during recording of biodiversity at European level, so these grids to be comparable and combined. So in this study, we use this European grid, and we use almost 3,200 cells, occupying a very big area. And you can see the area, the main study site area. As you described before, we use 4 groups of human pressures. The first was the marine traffic. The density of marine traffic by different vessels was estimated using available data by marine traffic database. Totally 8 different vessel types were analyzed: cargo, containers, fishing, gas carrier, passenger, pleasures, tanker, and tugs. For each vessel types, using a web GIS application of marine traffic, separate images of traffic were saved in high zoom to represent better the density of routes, resulting 60 to 160 images per vessel. For example, for more images were needed in vessel with high density to represent better the density traffic. This results in totally of more than 1,000 images for all vessels. These images that we collected from a WebGIS application were in a RGB format, and in order to quantify the density, as it was the ultimate goal, we convert this RGB to single information per spectrum. I see for RGB, we convert in air, green and blue RGB, so to have a number of this. So we can see one single bat with now with not RGB, but it's the values from 0 to 255. So in this way, you can estimate the density of the traffic. And in each vessel, we use the best spectrum that we can represent the density. After these conversions, for each vessel, we create the thematic quantity maps based on each vessel traffic type. So for each vessel, in the selected single bat of RGB, we overlay the main grid, and we estimate using a zonal statistic, the statistical value of each traffic. So you can see an example of tags with A, this is the mean value of the traffic, the standard deviations, and the sum of the traffic. In the subgroup analysis, we use only the sum statistics that was more important for our analysis. So you can see the results of this analysis, the sum value of the tanker traffic in our study area, the gas vessel traffic in some statistic, the cargo, the container vessel type, the passenger, the pleasure vessel type, the fish vessel traffic that you use in separate analysis you will see later, and also the tag vessel traffic. The next variable that you use, it was the port effect or the careta. This was to estimate a possible distance-based disturbance factor of port existence. And we use 116 ports found in marine traffic databases. You can see here with the blue dots. And in this analysis, we use a multi-ring port influence in 5 cycles of 500, 1,000 meters, 150, 2,000, 2,500 meters, clipped in the sea zone to weight the relative effect of port presence. And this value, after we record in a reverse value, as the 500 meters closer to the port is the highest effect, and the farther it's the lowest effect. So the distance of the 2,500 meters is only 1, but the distance of 500 was 5. The third analysis was the analysis of a bolt up area to the nesting beaches. So in this way, we use only the nesting beaches, the well-known nesting beaches in the Greek territory. And in this way, we use a very high analysis picture from a world imagery in ArcGIS online maps. And in this beach, nesting beach, we see with the blue lines. We estimate a zone of 200, 500 meters around this beach from the sea to the coast to estimate the built-up area. This analysis, it was difficult to see the relative effect of urban because you can have some places we have only one road, but some places we have a lot of buildings and roads close to the beach. So we use a specific analysis and with many steps to evaluate the effect of built-up area. At first, in the roads, we use a buffer zone of 7 meters in each side to formulate approximately coverage of road cover. In the next step, we connect and dissolve the urban and road polygons to have one polygon and convert this to raster format. You can see here in Crete, in Chania, built-up area around the nesting area, the nesting careta area. And to represent better the influence of the coverage, we use block statistics to have the sum value of a statistic value. And you see the block statistics. So in each block of 100 meters, we can have how many density points we have here. You can see different value of block statistics. And this file we convert in point format. So each point took the value of block statistics. So we have a big number, so more than 300,000 points in order this nesting area. And this after this point that has the number of block statistics, we like in the port, we estimate the buffer zone of this point, but before we'll multiply by 10 times to have better the effect. So you can see if we multiply by 10 times, we have 5, the number of coverage was only 50, but we have like 76, we have much more. So it was more like geometric, the effect of coverage. So in this way, we're able to to buffer this point, to have the real effect of coverage. You can see we have a lot of coverage, we have a smaller buffer, but we have a bigger buffer. So as in the port, also again, this we estimate multi-ring. So the first zone of coverage was the highest influence, and the other it was the lowest influence. So in this way, we estimate the effect of urban route relative to the nesting habitat. The last one, we use the plastic concentration and noise. In this way, we use the existing map available. So your reference is the existing map that you already on scale of concentration. We can see the scale. And this your reference after the map. We estimate as the previous variables, the mean value overlay the main out-grid study. So in this way, also after this, when we overlay the grid on this geological map with zonal statistics, we estimate the mean values and creating again thematic maps. You can see an example, this plus concentration, overlay on our grid study, and the noise value. So I give my time now to Haris Dimitriadis because there was a main possibility to estimate the vulnerability with the modeling. So Harry, you have time.
Good morning, everybody. Thank you, Mr. Porazidis. Now I'm going to move to the next step, to the next regional step that we have to follow. And next slide, please. Okay, so we have to say beforehand that caretta turtles are a highly migratory species, which in other words mean that they don't recognize state borders or jurisdictions. So if we want to conserve and protect those species, we have to think on a wider scale. So their playground is the Mediterranean Sea. So we need big spatial scales to understand the effect of the human-induced pressures upon their populations. Next. So when we were designing this project, we tried to have an integrated approach and try to find a feasible and easy to use methodology in order to have an overall vulnerability assessment for sea turtles across the study area. So it's reasonable to think that vulnerability can be calculated at each grid cell size and each threat, divided in 3 big categories. And these categories are the migration routes, the foraging grounds, and the nesting beaches. So for each of these categories, we produced an independent vulnerability index for each cell and each threat. And then we add on an additive model all the threats and producing this cumulative vulnerability index at each habitat. So this was repeated for migration routes, nesting beaches, and foraging grounds. And then the final step was subsequently lead us to have the overall vulnerability value per cell across the study area by adding the effect at its habitat. And how this was accomplished? In general, vulnerability per threat and habitat at each grid cell was calculated as the exposure to threat multiplied by its sensitivity to its threat. So in order to identify the exposure, we need a weighting criteria, which in other words means that not all threats have equal effect upon sea turtles. In other words, again, some threats are more important than others. So we did some surveys based on expert judgment opinion across the study area. And we had some structured interviews, and we asked for the experts to weight those threats. And then we sum up and took the average perception of the experts, and we translate them as the weights to the equation that calculates the exposure. So, and then it's sensitivity. Please get back a little bit. And then sensitivity is how exposed are the sea turtles for each threat, which means how sensitive they are. This was calculated based on the concept that the more time the turtles spend in one habitat, the more sensitive are to each threat. So that was the basic rationale behind these calculations. And we scored, we give the weight to sensitivity, and then we multiplied this by a measure of density of turtles at each grid cell, at each habitat of the study area. Next, please. So what we get, so different threats contributed differently to the vulnerability at each habitat. For instance, at the foraging grounds, fisheries had the biggest impact in the formulation of the vulnerability value, followed by floating plastics, maritime traffic, and so on. When we compiled the overall vulnerability at the study area, we found that the biggest source of contribution to this vulnerability comes from the foraging areas, followed by the migration corridors, and having a smallest amount by the nesting environment. And this is quite rational because the foraging areas are more spatial diversified and cover a bigger extent than the migration corridors or the small scale nesting level. Next. So you can see in these maps the vulnerability for each threat posed upon sea turtles. Next. So that's the case for the foraging grounds. And this is the case for the migration corridors. Next, please. And then by adding the effect of the nesting habitat, the migration, and the foraging ground, we get the overall vulnerability in the study area. Next. So, what's the big fuss about it? What we can do with these maps? Are they of any use? Well, we can say that spatially identify hotspots for the implementation of specific conservation and management actions is of great need nowadays. So if you know where are the hotspots of vulnerability, then you can narrow down the areas that need conservation. They have a biggest priority for conservation, therefore reducing the costs of conservation, the effort, and all the issues related to in order to achieve conservation and management actions. Secondly, you can also inform stakeholders and decision makers for governance issues. And you have a spatially explicit management tool that can be easily be of use by decision makers and policy makers. So it's very important to say that nowadays vulnerability and risk assessments are recognized at the higher political level and European strategies and directives. So with this study, we set the basis for the implementation of Marine Strategy Directive and Marine Spatial Planning Directive, since Caretta is used as a criterion species for these directives, and therefore this study can be used as a basic background knowledge in order to formulate and implement those regulations. And also we can set priorities for blue growth. This means that this map can inform us where we can have intense or less intense blue growth across the study area. Next. Thank you very much for your attention.
Thank you both for the interesting analysis. We have a small change in the schedule. The next presentation will be by Professor Antonis Mazaris and Vasiliki Albanidou from the Department of Ecology, School of Biology of the University of Thessaloniki. They will present the modeling future distribution of loggerhead sea turtles habitats in the Mediterranean. Please, Mr. Mazaris.
Can you see my screen now?
Yes,
there?
we can.
Okay, so you can just see that. I think it's okay. Is it? Okay.
Perfect.
I'll try to be short because I think that Kostas and Panos actually spent half an hour talking about very interesting things. I can see many faces, many good friends in this conference. I can see also many people that I guess are really interested on this project and also on marine turtles. So as I told you, I'll try to be short. I'm going to show you some of the methods that we are using in order to be able and understand where the habitats of our species are and how, let's say, how vulnerable they might be due to the risk of climate change. But before I go through the analysis and the results, I would like to spend just a couple of words for BlueCoast. It's an interesting project. You can see that there has been a lot of work that has been done. And at the same time, I see that it has a great potential because many of the analysis and many of the outputs of this project, including what I'm going to present you for the next few minutes, are directly linked to two key aspects. One of them is the Marine Strategy Framework Directive, the MSFD, which is a key strategic document, strategic directive for the European Union in order to achieve good environmental status in our oceans. And the other item is the important marine turtle areas, something that we try to, as a group, the last years to deal with and delineate those areas across the Mediterranean. So this BlueCoast project actually overlays, covers, expands really critical needs in terms of policy, in terms of conservation. Just one note regarding the MSFD. For those who don't really know, there are several different kinds of descriptors, and each one of us, for each descriptor, we have to take some very specific measures and make some decisions on how to proceed. So what I want to show you here is D1, C1, for example, is the descriptor that deals with biodiversity, and C1 is a very specific criteria that we need to address. And this is, once again, once we talk about the European Union, this is a directive that means that this incorporated into our national responsibilities, at least for the member states. So talking about species like the loggerhead sea turtles that the guys before talked, and I'm going to talk, there are some very specific criteria that we need to have a very clear idea in order to fulfill the requirements of the MSFD. One of the criteria, the first one, is related to bycatch. The other one is related to population size. The third one, demographic characteristics. But the two last criteria are related to habitat, species distribution area, and habitat for the species. So you can see that Harris mentioned in one of his last presentation, of his last slides, the MSFD, and you can see here how critical it is regarding our understanding and knowledge for the habitat and the distribution of the species. In terms of, once again, fulfill our obligations as member states, apart from acting like conservationists, okay, and managers. So I will start with the life cycle of marine turtles. I guess most of you are familiar with that. We have different life stages. The nesting sites, from where everything starts, we have eggs there. They, after a few weeks or months, 1.5 months, let's say 2 months, they become hatchlings. Then they start swimming like crazy for 3 days and then disappear for many years. And this is the phase that I have here, like C. This is why it's highlighted. We don't know many things about this stage. We don't know where they are, how many they are, and so on. But after that stage, we start gaining more and more information. So we're talking about juveniles, that they become slowly mature, and then they mature using very specific foraging grounds and return to the breeding areas and so on. So to be honest, when we're talking about sea turtles, we have a huge gap related to many of the habitats, but mainly if we talk about life cycle, we have a huge gap regarding this first stage of very young individuals. So what we have is information about the nesting sites, the foraging areas of juveniles, and the foraging areas of adults. But still, apart from published data and very precise info on the nesting sites, we are actually missing at the Mediterranean or even at the global scale a clear representation, identification, how can I say that, mapping, delineation of the foraging areas, both for adults and both for juveniles. So this is a critical, in order to be able and fulfill once again the requirement of MSFD, but also improve our understanding and knowledge on how to effectively protect our species, we need to move from the nesting sites to the marine realm and identify those foraging areas, or actually their marine habitats. And this is what we are trying to do with my team the last several years. Nesting sites and climate change, once again, okay? So nesting sites of loggerheads, in order to be able and assess the climatic vulnerability, obviously we know where the nesting sites are, okay? This is the very simple thing, that's why I start from here. We know them, we have plenty of information. There are some new records of nesting sites that are start to be used by the animals year after year. So we have few nesting sites in Spain, few nesting sites in Corsica, few nesting sites in Italy that are visited very occasionally by only a limited number of animals. But still we are able to monitor and count them. So we know where the nesting sites are. But what we didn't know, what we don't know, is their suitability and their potential suitability to climate change. Their suitability in terms of the environmental conditions, how good they are in order to produce viable hatchlings, and how many of them and which of these nesting sites will be suitable in the future. So what we did, we collect information about all the available nesting sites in the Mediterranean. We divided in two different groups, those that are considered as constant, stable, they support a large number of nests per year, they host a big number of individuals, and then those sporadic, those that over the last 10 years or something, they are only sporadically visited by the animals. So in order to assess their climatic suitability and try to explore which of these sites will be climatic suitable in the future, we have to use, once again, models. So we derived climatic data sets on air temperature and precipitation, because we're talking on the terrestrial or the coastal environment. And also for, let's say, current or recent past, but also for the future. And we extract this information by combining different types of global global climatic models, not using just one climatic model, but using a group of them. So next we have to create specific climatic variables that reflect the stage, the period at which the animals come and stay at the nesting grounds. And then we have to develop a number of climatic niche models for which we have used different kinds of techniques: generalized linear models, general scientific models, maximum entropy. Many of these tools for many of you are might sound very complicated, so I'm not going to put any more details or any more give you any more information at this stage. Just have in mind that these are tools that allow us to predict the potential suitability of a given area based on environmental variables and the presence and information that we have about the presence of my species, or actually the subject of interest. In this case, we're talking about nesting sites. So different type of algorithms, different type of models. This allows us to create climatic suitability maps. And based on this kind of framework, we have developed an indicator that allow us to investigate whether the climatic suitability of nesting sites fell above or below this indicator. So allow us to set a threshold on which is the best climatic conditions that support viable populations, and actually what will happen in the future for our nesting sites. So we get kind of results like this one. We get information for the current period, current conditions, and future conditions. You can see here that the maps on the right side of the screen are related to only a few months, and this is done in order to capture the window, the temporal window at which the animals visit the nesting sites. Okay, it doesn't make any point to use in the Mediterranean, for example, information on climatic information on December or January for the nesting sites, okay, because just the animals are not there. So you can see that with red color, we have more suitable climatic sites, and you can see how this might change in the near future. You can see which sites might be improved and some areas that might become a bit worse in terms of their suitability. In any case, our outputs suggest that about 85% of the sites, of the nesting sites, actually manage to fall above the indicator under future conditions. What does that mean? I can translate it in a very simple way. We still have to focus on the nesting sites that we really know that are doing pretty well now. So we need to keep on working on them. We need to keep on running monitoring and conservation programs, since even within the next 80 years or 90 years, they're going to be climatic suitable based on the conditions that we are able to model. Something for those of you who are a bit more familiar with the biology of the species, you know, many of the animals, what they do in order to adapt to climate change, they gradually change the temporal window that they start dealing with some of their biological features. Some of the birds migrate earlier, some others might, in order to capture once again this favorable climatic window. Some other species might develop their eggs a bit earlier, and so on. This is also the case for sea turtles. We have observed, we have reported that every single year, when it comes, for example, to zakynthos, few days are coming, every year they're coming for a few days earlier to nest. So we're talking about a period that if you add in a 30-year, let's say, time series, that can give us about a month, right? So let's say that the next 50 years, 2050 or 2060, it is very likely that we're going to see marine turtles nesting the zakynthos at the end of April, for example. So we also wanted to test this kind of biological feature and how it might affect our modeling outputs. And actually, it was rather, let's say, optimistic, the outputs. It doesn't matter if they gradually change their their behavior, their phenology, their initiation of their nesting. The nesting size is the left box plot that you see under the panel A. The big size, the stable size, all of them are going to be above the climatic threshold. So they are going to maintain favorable conditions. This does not apply to the sporadic nesting sites where we don't really have a clear signal. So once again, considering or not phenology, we have to stay focused, or we still have to focus on the current nesting sites. I will go to the foraging areas, marine realm now. What do we know? Very little things. We know that the Gulf of Gabes and we know that the Adriatic Sea hosts foraging areas for adults, but we have no clue what is going on to the rest of the Mediterranean. So with the help of many MSc students and many PhD and postdocs, what we did, we tried to collect information on the foraging, every information that we're able to find in the gray and the scientific literature, from tracking data, and then we were able to extract the locations of foraging grounds. Have in mind that this was not very easy, because if you have a track, in some cases, you will have to digitalize it, and then we have to see when the animal starts moving in a smaller area or moving rather slowly in order to say, okay, it has reached or it is actually located in foraging ground. So we spatially, we digitalize this information, and once again, we play now with climatic information on the marine realm and try to select the best potential predictors for our models. This is a picture that shows us how it works: generalized linear models, generalized scientific models, boost model, a combination of tools in order to predict based on the environmental variables and the locations of the species, the full range of suitability for the Mediterranean Sea. So what we end up is a map that we were missing so far, a map of the foraging areas of the adult sea turtles in the Mediterranean. And then we got it, we were really happy with that. And then we noticed that there was something wrong. And the problem was this location here in France, close to where the MedPan team stays, so close to Nice and Marseille, that we identified some red spots, which means suitable areas for adults. We have no clue that this was kind of critical. There was a kind of problem or concern regarding the red sites here. Red means better suitability, very suitable foraging areas. Red areas in the Aegean Sea. So we were happy with the output, but does it work? That was the question. So what we did as the next step, we communicated with a group of good fellows and good friends and colleagues from around the Med in order to extract information that was that has never been published, that has never been used before, information collected from field data, from some very strict, some satellite programs with very strict restrictions on use, And what we managed to do, we managed to add for those locations for which we were missing data, you can see the yellow points here, we were able to add more info about the spatial distribution of our adult animals. And then we ran another statistical analysis. And actually, we were very pleased, very happy to see that our model did pretty well in predicting the foraging areas, even for those for several sites for which we had no clue that they served as critical foraging areas. So using this not very common validation method, we were able to say that the current map works pretty well. So what will happen in the near future? Taking climatic variables and project our algorithms to the future data. And this is what we get. You can see, as a general conclusion, you can see that we have a shrinkage. We have a reduction of the suitable foraging areas for loggerheads within the next 70 years. So we are waiting to see that they are going to lose almost 1/3 of their current distribution. But we can see that there is a kind of increase in climatic suitability at the areas of the Eastern Mediterranean. So this is something that we didn't know, and this is something that should definitely be used in order to identify important marine territorial areas at this stage, but also help us to gradually build our next steps for the future. So adults and then juveniles. Repeat kind of the same process, collect data for juveniles, every available part of information. A PhD student, Anastasia Hadjimentor, was leading these works. She has done a fantastic work for this task, along with Vasiliki Albanidou. We were able to extract and digitalize all movement patterns for juveniles, but believe me, that was messy. That was a clear mess. You can see here just one part of the map, big lines, tracking data, following the same individual. So we had to find a way, we had to find a mean in order to set some thresholds and identify those potential foraging areas, use them as points in order to run our models. And we also have to make some very interesting adaptations to our modeling scheme in order to use potential absences. So this is a kind of technical thing, but just have in mind that in adults it was rather simple, let's say, but for juveniles it was a complete nightmare. Still, we managed to play with different climatic variables on sea surface, built upon sea surface temperature. And as I told you before, Untechnical Thick develop a kind of framework that allow us to identify, to build the models in a more robust way. And then we had an output like that. So we had an output about the current foraging areas of the juveniles in the Mediterranean. Red colors means more suitable areas, and as it becomes bluish, it becomes less suitable areas. So this is for now. For those of you who are not familiar with our literature, have in mind that this is the first time that something like that has been developed in the method. It's also the case for adults, but for juveniles, we used to have even more limited knowledge. So what we see some well-foraging areas at the North Atlantic and Gulf of Gabes in Chinis, and this also serve as critical foraging areas for adults, we know that. And something else, we don't have nesting sites at the eastern part of the Mediterranean, but you can see that we have many critical foraging areas at this eastern part, at the western part of the Mediterranean. But we have many critical foraging areas. So this actually makes a kind of a puzzle, where and how should we protect, and which are the important areas. For juveniles, the western, for adults, actually very fragmented locations in central and mainly in eastern Mediterranean. So what happened in the future? In the future, we see that things are going to change. The temperature, we know that it's going to change in a very, let's say, I would say more uniform patterns than what we expect for precipitation. So these patterns will result to an increase of suitability at the eastern Mediterranean basin, where we also have many different pressures and threats, and where we have many gaps on the pressures and threats for the animals. For example, we don't have enough information on the bycatch. We don't have enough information about fishing activities. So these are areas that will become very important for our populations. And at the same time, what we get is a kind of shrinkage for the suitable areas under the current conditions. I will go to the next steps, just in order to be able to finish in 2 minutes. Migratory corridors. This was mentioned by Kostas Perazidis. This was mentioned by Haris Dimitriadis. Corridors. It's very complicated how to identify those corridors and how to deal with these corridors and how to evaluate their potential suitability under climate change. So what we did, collect of migratory routes. We used some linear kernel methods, some kind of density, let's say, functions, spatial density functions, in order to transfer those lines into polygons. And this is something that you can see in the lower figure in this slide. we had to identify climatic data once again at the marine yard, extract then climatic data along the corridor, and then compare the current and the future climatic information. That was very tricky as well. This is a work that Kiki Albanidou spent several months on dealing with that. It was part of her PhD. So because just see the picture further down, you can see one corridor here and how we actually deal with that. We have to take slices of every three days for every corridor, because we were able to estimate the movement speed of the animal. And okay, they are going to make, let's say, 2 weeks in order to go from Zakynthos to the Adriatic Sea. So I don't want to take all these 2 weeks and compare the climatic conditions for every single point. Sorry, for the whole corridor. I had to split the corridor based on when I'm expecting the animal to be present within this migratory period. So we have to split based on the temperature, based on the speed of travel. We have to split the corridors in very small slices, and then we had to extract climatic data for those slices and compare them with the future data for the same period. So, complex story, interesting findings, sea surface temperature along migration corridors and future corridors. What we obtained is a significant increase within the next 80 years. Logically, we expect it. Have in mind that increase of temperature could mean many things for sea turtles, okay? It means the energy that might need to accumulate. It means it might be related to their health. It might be related to productivity. It might be related to the initiation of migration, metabolism, oxygen consumption, and so on. That's why we study it. That's why we care about it. And once again, SST, this is the way that the corridors and the different colors in terms of change of temperature looked. SST, sea surface temperature, will increase significantly within the next 80 years along all the distinct corridors that we were able to identify in the Mediterranean. And here is another very interesting output regarding the percentage of cells. So we're talking about hundreds, maybe thousands, I don't remember, number of cells within each slice for each future SST, for which each future sea surface temperature fell outside the range of the current conditions. So might be rather hard to interpret this figure, but you can see the crosses, and this is what I care about. You can see that we have many crosses, and means that in every single location of our corridors, the conditions are going to, let's say, significantly, if not dramatically, change within the next years. And this poses an additional challenge for us. This poses an additional challenge for those who want to plan and design the next conservation steps. So what's next? In terms of BlueCoast, obviously, what the guys mentioned earlier about the vulnerability indices and the overlay with the pressures and the threats, obviously, we had to produce those kind of habitat maps at the Mediterranean scale in order to use part of them also for the BlueCoast, for the objectives of BlueCoast. So this kind of outputs, part of these outputs were cut and used for the objectives of the project. At the same time, as I mentioned, there are two critical aspects. We have discussed it several times with the guys from MedPan and some other colleagues from the Med. What we need to identify important marine turtle areas. And what is critical for us? D1C4, D1C5. Before I close my presentation, just to mention that last week we had the meeting with the European Joint Research Center organized by the European Joint Research Center from ISPRA and the French Ministry of Environment, where we had to identify, to standardize those kinds of criteria and identify indicators for each one of these criteria. So that could probably be applied at all the member states, adapted, probably used in order to develop monitoring programs and protection actions for all the EU member states. So what we've tried to do here, and part of the BlueCoast program, was to improve our understanding on the habitats of the species, explore their climatic vulnerability, understand how this will be affected by the changes in the climate in the near future, and feed this information to the requirements of the MSFD as the final goal. So once again, thank you for your attention. I really apologize if for some of you, some of, let's say, the tools or the outputs might sound a bit strange, but hopefully you were able also to concentrate on the images, and that was my intention, to see that we can, and now we have maps on the most important habitats of sea turtles, and also we are able to understand which of these habitats are going to be threatened by climate change the most. Most of this part of the information, once will be published, will be available from the websites of my group and so on, for anyone who might want to use those kinds of layers. So once again, thank you guys.
Thank you, Professor Mazaris. Very interesting presentation. Moving on to Stavros Kolios from the Laboratory of Meteorology and Climatology from the University of Ioannina, and Anastasios Kalimeris from the Department of Environment in the Ionian University, satellite-derived climatic variability in the Ionian Islands. Stavros?
I think it's everything okay.
Yes.
To you. Can thank you for the opportunity to present our work with Professor Kalimeris and my contribution to the very interesting project BlueCoast. The title of this work is Satellite-Derived Climatic Variability in the Ionian Islands and their greater area. A part of this job, this work has already done by Professor Kalimeris, and another part of this work in this work package is performing in this period by me. First of all, the main objective of this work package is the integrated climate variability assessment through the thorough statistical analysis and the spatial mapping of satellite-derived time series of various parameters. Secondly, the selected parameters concern modern graded remote sensing data and products as well as reanalysis data that produced using different multispectral remote sensing data as initial information. The selected parameters are included among the basic climatic indices of the atmospheric and marine environment across the Ionian and Adriatic seas. At this point, I have to mention that the previous speakers, Professor Porizrazidis and especially Professor Mazaris, has already spoke about the importance of the climate variability, the climatic conditions, and the potential climate change in the greater area. So, more specifically, the data and methods are collected and used for further analysis in this work package, include sea surface temperature from the satellite instrument MODIS on board of the satellites Terra and Aqua, and also can be seen the period, the spatial resolution, which is one of the most higher spatial resolution you can find equal or more advanced among the fine resolution models is this satellite data. Also, we have collected data about an index which concerns the absorption coefficient of phytoplankton, chlorophyll A, air temperature, shortwave radiation flux, and precipitation data from TRMM satellite. First of all, a small general flowchart, schematic flowchart about the procedures we followed during this work. We started with data collection, more than 1,000 gridded data files, which means millions of pixel data to handle, data preprocessing, an automatic check of possible null data and reformatting. We followed the whole procedure with data analysis, which translated to statistics, mean annual, monthly, seasonal data, linear trends, statistical significance of these trends, and the variability, all on pixel pages. All this huge amount of data and analysis were performed by developing personally programming code in a Visual Basic environment in order to handle and produce all these statistics. Finally, maps were produced about these statistical values, final figures and tables with statistics in order to have an integrated spatial analysis using GIS mapping capabilities. I'm going to some characteristic results about the work is performing in this period, as I told you before. First of all, the important parameter of sea surface temperature. On the left side, on the left figure, you can see the mean annual variability according to the period of 2002 to 2018. It can be seen in this figure a statistical difference in the mean annual SST, sea surface temperature, between Adriatic and Ionian Sea. The Adriatic Sea is colder than Ionian Sea and in mean values, in mean annual values terms, while on the right side of this figure, you can see the trends during this period where this data were available, and we can see that the positive trends along the coastline of Western Greece, Albania, Italy, Peninsula are depicted, which is consistent with the findings. Some findings were already shown especially from Professor Mazaris. Excuse me. Also, it was depicted as small negative trends in the Ionian Sea. Regarding the mean, regarding the seasonal, the seasonal spatial variability, the Ionian Sea is warmer than the Adriatic during all seasons, as in annual basis, obviously, and the coastline of the Western Greece, along with its islands, has slightly warmer SST values than the central Ionian marine region. Going to the trends, it was found that seasonal trends are very small in all seasons, but positive trends were found, especially in winter, and more extended are in spring. Gray shadowed regions in the on the right side on the top of the panel can clearly depict this statistical significant trends, positive trends of sea surface temperature. Going to another important parameter, the chlorophyll A concentration. The mean annual spatial variability shows that coastlines of Western Greece, Northern Albania have the highest values of chlorophyll A concentration on annual basis, and also very small but negative trends of chlorophyll A concentration is depicted over the whole steady area. In seasonal basis, the chlorophyll concentration shows that the highest, the maps of the chlorophyll concentration shows that the highest values are depicted especially during winter and spring in semi-closed marine areas, Ambracicos and characteristically referent Ambracicos and Patraikos Gulfs, as well as in Puglia region and the northern part of Albanian coastline. Regarding the trends, the seasonal trends of the chlorophyll concentration, it was found that small positive seasonal trends are depicted during winter and spring again along Ionian Islands and the Apulia Peninsula respectively, and also small negative trends spread out across the largest part of the Ionian and Adriatic seas during autumn. Going to the to precipitation, I provide in this slide the monthly distribution over the land, but these maps will be updated using more recent data and considering and marine areas in the technical report of this work package. Characteristically, I'm referring in this slide that the highest amount of precipitation amounts can be found in the Adriatic, in the Dinaric Alps and all over the Western Greece, especially during winter and autumn season and the relative months, because the raining period starts from September in the greater area and starts to decrease at late spring. In the red polygons, you can see the study domain, and you can see also the precipitation patterns in annual basis on the left and in seasonal basis on the right in the greater area of Central Mediterranean, where, as I mentioned it before, the main the highest amounts of precipitation are constantly located along the Dinaric Alps, the Pindus Peninsula, and the coastline of Western Greece, while in autumn there is important high amounts of precipitation all over the Ionian Sea. The air temperature, regarding the air temperature, again provided maps on monthly basis, but there is an ongoing work to produce maps at seasonal and as well as in annual basis, in more recent using more recent data. Clearly, it can be seen in this monthly maps that the clear difference between sea and land, the variability of air temperature between sea and land regions, and also there is a latitudinal distribution which is characteristically between Adriatic, which is more cold than the air temperature in Ionian Sea. Also, I have to mention there is ongoing work to produce such maps in such categories in seasonal, annual, and monthly basis in two other critical parameters like the shortwave radiation flakes and the absorption coefficient of phytoplankton. And finally, I have to mention that now an extra work was done by selecting some sampling locations in order to calculate these specific locations, which is of high interest during the framework of the project, to calculate, as I told before, all these parameters, all the statistic values, not in the greater area of this region, not in spatial distribution, but exact locations, the temporal evolution of these parameters in the exact locations you can see in this figure. characteristically is referent that the sea surface temperature about these nodal points and how how is the temporal evolution of these parameters along the long time series of data sets. Going to general conclusions, a climatic analysis of recent 16 to 20 years time series of spatial data, variability and range of basic atmospheric and marine parameters was performed. Climatic maps of annual, seasonal and monthly climatic maps on annual, seasonal and monthly basis were produced. The high quality of the datasets can be used as a driver for further analysis about the climatic conditions, the current climatic conditions of the greater area to understand the mechanisms and the behavioral tendencies of the flora and fauna across the study domain. And finally, the climatic analysis is vital to assess the vulnerability as well as the types and the density of the risks of numerous ecosystems and protected areas of the study domain. Thank you.
Thank you very much, Stavros. Moving on to the Department of Marine Sciences of the University of the Aegean, Spiros Pondilis will present a geospatial web service for chlorophyll concentration mapping with the use of remote sensing data in Zakynthos.
Hello, can you hear me well?
Yes, we can hear you. Please share your screen.
Yes, of course. Can you see my presentation?
Yes, perfect.
Greetings, I'm Spiros.
Please change the screen because we see the preview.
Okay. Let me see.
Display settings. Swap.
Okay.
Thank you very much.
Greetings again. I'm Spiros Pondilis from the University of the Aegean. I am a PhD candidate in the Department of Marine Sciences and member of the Marine Remote Sensing Group. For the BlueCoast project, I, with the help of Professor Topouzelis Konstantinos, were tasked to provide a geospatial web service that produces and publishes chlorophyll concentration data with the use of remote sensing data. So the project involves two main components. First, the selection and application of a suitable chlorophyll estimation model, and then the establishment of the web-based infrastructure. In addition, other goals involve the applicability of the models to data with various spatial scales and resolution, the build of a multi-year data series, and the publishment of the results online. All of those targets should be enclosed within an SDI or a geospatial web service and be public for users to interact with. Our study area is the middle to lower part of the Ionian Sea, focusing mainly around Zakynthos Island, but because we use different data with different scales, we made a distinction between finer and coarser resolutions. Fine resolution data are used mainly for small regions, like the Gulf of Laganas and marine regions around Zakynthos Island, and lower resolution data will cover larger areas of the Ionian Sea. For the estimation of the chlorophyll concentration, we decided to use three different datasets with different resolutions from Sentinel-2 and Sentinel-3 satellites, and some services with already processed multi-satellite data provided by the Copernicus Marine Services. Sentinel-2 data have the higher spatial resolution of 10 meters, but also the lowest temporal coverage and footprint. Sentinel-3 data give a resolution of around 300 meters and can cover an area larger than the Ionian Sea, but it depends on the date. And data from Copernicus Marine Environmental Monitoring Service are of 1 kilometer spatial resolution. They are produced daily and cover the whole of the Mediterranean Sea. Before I present you the methodology, I want to explain shortly the mechanism behind it. On its basis, downwelling solar radiance is absorbed by the water column, and a small percentage of it is backscattered backwards through the atmosphere. This upwelling radiance is what actually the sensor measures. But the level of the absorption from the backscattering is not only determined by the water, but also from its constituents, such as chlorophyll and other particles. Each constituent has its own absorption and scattering rate, and these are called their inherent optical properties, which are individual. They're specific for each component. Through them, we can determine the concentration of each particle that is contained within the water column. However, phytoplankton consists of various species that all have different inherent optical properties because they are different from each other, they're different species. But due to the chlorophyll that is the main pigment of their cells, they all present high absorption rates at wavelengths around 400 and 500 nanometers, and also at the 670 nanometers. This behavior is their spectral signature, and models try to exploit that. The methodology is consisted of 4 main parts: the data acquisition, the pre-processing, the chlorophyll estimation, and finally the geospatial web service part. The first 2 are for acquiring the data from the automatic acquisition of the data, from different European repositories, and the basic pre-processing needed for further analysis. In the chlorophyll estimation part, the models are applied to the data and some necessary post-processing is performed so that the results are more readable and ready for use. After that, the results are transformed to a web mapping service. The metadata catalog is updated, and then the services are published through the geospatial web service. And the cycle repeats whenever there are available new data. For the project, we currently tested 3 models. The first and second are the maximum chlorophyll index, MCI in short, and the Mediterranean Ocean Color 4, which are both empirical algorithms, and they rely on estimating chlorophyll through the ratio and the relationship between different spectral wavelengths. MCI uses the radiance of 3 different bands and is applicable for Sentinel-2 data. The Med Ocean Color 4 relies on the ratio of the reflectance of 2 wavelengths, but the wavelengths can vary depending on the type of the water. Basically, if they are more turbulent or clear, case 1, case 2 type of water. Finally, the C2RC processor is used, which is a neural network that targets to directly estimate the inherent optical properties of the water column, and from that, the chlorophyll concentration. The web service is divided in 3 interlinked layers. The first layer, which is at the bottom of the graph on your left, is the data layer where all data and their respective metadata are stored. Next is the application layer, where all the commands that the user issue are performed by drawing what necessary data from the data layer. And finally, there is the end user layer, which is basically the user interface, where all available tools and icons are available for the user to interact with. This interaction is with the application layer. For the infrastructure, we used various open source software like the GeoServer and the GeoNetwork softwares, which are responsible for the metadata cataloging and the visualization of the data. The WebJS interface is built from the by the Geospatial Enabling Technologies company. And we also have implemented a PostgreSQL database in order to store vector data. Currently, there is no need to store vector data, but in case the need arises, for visualization purposes for the chlorophyll data, we have the option to do that. Here, we present some pilot results of the chlorophyll estimation methodology. The first two from the left images are processed data with the C2RCC processor, and they are from Sentinel-2 and Sentinel-3 data series. On the right are already processed data from Copernicus Marine Environmental Monitoring Service. And at that point, I should note that these data are not from the same dates, and they are not directly comparable. I present them to you mostly to visualize the difference in resolution that the data sets can provide and the level of noise that is shown in low resolution data sets. Now I'll present to you the web service. On the middle in the interactive map and where the data are visualized, I have preloaded the service with data from Sentinel-3 and Copernicus Marine Environmental Services in order to demonstrate it to you. The top toolbar offers various tools for navigation, searching by name and by value, and also making measurements like distance or areas and making annotations. On the left toolbar is the layer tree. Here users can see all available data, their metadata, and they also can download them in commonly used formats like TIFF, KML, or PDF for quick reporting, and in case if there are vector files in shapefile format. Also, I would like to note that here users can also load their own data or from other web mapping services if they want to overlay them with the data we provide. The bottom tab is the search results, and there all query results are printed. Also, where the blue dots are, where you can see the blue dots, users can also scroll between dates to visualize data from the historic data series. Finally, on the right tab, there are the search tools. Here, queries can be issued based on the spatial resolution between different data. Closing, I would like to highlight some of the strong points of our project. From the data perspective, the fact that they are daily and multi-scale means that they can be used in any application if there is a need of them. And because they're already processed and ready for use, the integration in other applications should be simple and fast. Also, the service is open access, which means that it can be optimized depending on its specific need. It is also easy to use, so no technical expertise is needed. And it will contain a multi-year data repository that can be used as reference. Not all the data series is not yet accomplished, but in the next weeks we have ready the service and you can interact with. Thank you for your time. I finished my presentation.
Thank you, Spiros. Always interesting facts come out from your laboratory, from your group.
Thank you very much.
Moving on to session 3, marine policy, and we will start with Joaquim Carabou from the Institute de Ciencias del Mar, Spanish Research Council, who will present the MPA engaging Mediterranean key players in ecosystem approach to manage marine protected areas to face climate.
Good morning.
Good morning, Joaquim.
Just a second, I'm going to share my screen. Where is it? Okay. You see now my screen?
Yes, we can see it, please.
Okay. Thank you very much for the invitation. I'm not going to present such a wonderful images and results that the previous speakers presented. I'm going to talk more about what is our approach in this project that is funded by the Interreg Med program. And I highlighted in yellow the key words that we are working on. It's an engaging and people, stakeholders in marine protected areas to face climate change. So I know that you have a really heavy schedule today. So I just want to ask you for the attention. If you want to skip the later part of the presentation, I'm not going to blame you because you have many things to do, but please stay for the first slides because I think that they are the most, the messages, the key messages are there in the first slides, okay? So the first message that I want to stress that is already being said in the previous presentations is that the Mediterranean is a hot spot for climate change. And in fact, at the regional scale, we are around 1.5 degrees from the pre-industrial temperature. So we are living what the Paris Agreement is trying to stop, right? So we are kind of a laboratory where the people can see what is going to happen if we don't stop the current trends or the ongoing trends on the climate change. So there is a map with the warming rates in the different ecoregions of the Mediterranean, and you see that this is not an homogeneous warming rate. It can vary depending on the region, but everywhere this is happening. And this is associated to the different environmental processes like the increase of the occurrence of marine heat waves, for instance, and it has an impact, a clear impact on many ecological aspects, and it's making that the Mediterranean ecosystems are being transformed by shift in species distribution, mass mortalities, and the arrival of introduced or invasive species from elsewhere. Okay, so we have a huge problem to solve, and in fact, within the MPA Engage project, is that we want to contribute to the adaptation and mitigation of the climate change in the Mediterranean. And in the next slides, I'm going to explain what is our vision, how we can make this contribution. So it's to put marine protected areas at the front line for adaptation to climate change in the Mediterranean, because you know that there's already a marine protected areas and network in the Mediterranean. There are international commitments to increase this percentage of protection in the Mediterranean and enhance their management. So we have this opportunity to use marine protected areas, and this has been highlighted by many. It's not from MPA Engage project. It has been highlighted by different from different organisms and conventions and documents and reports, etc. That I put here some of them. but they put in these reports the reasons. But I wanted to highlight what are the main reasons that drive us to use or to work on marine protected areas. The first one is that we can have a sentinel observatory network on climate change effects in the Mediterranean, because many other of the human activities or human impacts have been removed or they have less impact in those areas. So we can really disentangle the effects of climate change. The second pillar or issue that is why we want to work with marine protected areas is because they are privileged areas to promote engagement of the stakeholders, and especially in the Mediterranean, marine protected areas are really huge attractors of visitors. So we can take this opportunity to raise awareness on climate change issues and make that contribute to the transformation that we need in our productive system. And finally, marine protected areas are enhancing the ecological, and if we do this process of engaging key stakeholders, we can as well enhance the socioeconomic resilience faced to the climate change. So these are the key questions or the key items why we are working, or why we think that marine protected areas can be really useful for the adaptation. Okay. So what is our mission, in fact, in NP Engage? How we think that we can contribute to do this? So we are working in many activities that I don't have time to explain in detail in this presentation, but I want to keep you these two issues. That we want to provide an harmonized framework for the development of local adaptation action plans. So this means producing reports, producing documents, capacity building, events, training elements, and databases that can be used for everybody. And the idea is to transfer, and this is the second issue that I want to highlight, it's transferring this framework across the Mediterranean NPA's network. Okay, so how we plan to do this is, which is also one of the driving processes that we are conducting within the NPA Engage project, is empowering local actors. This is mainly in our case, marine protected area managers and people that works around the marine protected area, and enhancing collaboration across the Mediterranean. This means with these stakeholders, with marine protected areas managers, with scientists working on those areas, with the fishermen, etc. Okay. So I'm going to give you an example on how this we are doing this process. I'm going to take the example of monitoring temperature conditions in the coastal areas, which is something that it was really needed to understand what was going on the climate change. So we created more or less 15 years ago the TEMENNET platform, where we propose a protocol to measure with temperature data sensors the temperature conditions in the water column. But we propose this protocol, but we also provide the tools, the video tutorials, for instance, on explaining how you can set up a monitoring site for temperature, or how to use the TEMENNET platform to upload the data and to manage your own data. Okay. And finally, we provide different tools to visualize the results of these monitoring activities. Okay. So we set up this temperature. The protocol that we propose is to set up this temperature data loggers at different depth, from the surface up to 40 or more deeper depth. And this has been a very successful initiative, because you see here the growing. I don't know if you see my pointer, my mouse, but it is the increase of a number of monitoring sites from the early years 2000. So we currently have more than 70 sites that are using this protocol, and this in your right figure here, it's showing the number of data points that we have been collected, and we are more than 18 million data points that have been collected across the Mediterranean. So this, for us, this is the way to go to provide an harmonized or standardized protocol, and then provide all the tools to make it happen, to make easy the implementation of these protocols, from the field activities up to the data visualization with all the different steps. So we have been doing different trainings and preparing different materials. Sorry, not going more into detail of this, but you can find more information at the project website. Okay, so what I'm going to provide here a really fast overview on how we are developing these adaptation plans. So the first thing that we have to know is monitoring what is happening, knowing what is happening in your marine protected area, collecting the information about the impacts or the effects that climate change is having there, about the habitats, collecting information about as well on the scenarios of future climate change effects on these areas. Then we are conducting socioecological vulnerability assessments. So we, at the scale of the marine protected area, so with all the data collected in the previous phase, we are conducting these vulnerability assessments, both in the ecological side and as well on the socioeconomic activities working in the marine protected areas. Then we will be conducting participatory processes with the key stakeholders to show what are the impacts, what is expected to happen, what are the vulnerable areas or activities faced to the climate change. So with this discussion and with this information, we will be proposing or developing an adaptation action plan. And in fact, this is going to come with a list of actions that they will be implemented in each marine protected area. And again, then we will be monitoring if these actions that we have been proposing, they have the expected result or not. And then we will, it's going to be a feedback on the process, and then we will check again if the adaptation plan or the list of actions, they are adapted or not to the current situation. Okay, so this is a really fast overview on these activities, and for all these main activities, we provide this capacity building, all these training materials, and try to implement this philosophy about transferring. So it's we are conducting this within the project, but the idea is that all this information is going to be delivered at the Mediterranean scale. So just to finalize my presentation, some main figures of MPA Engage. So we are 14 partners from 7 countries, including Greece and Albania, that I think that is of interest for the BlueCoast project. We started more or less 1 year ago the project, and it's going to be finalizing in June 2002. And we had a budget around 3 million euros for these 14 partners. And it's really important for me that to stress that the partnership is not only numbers, is that we have a group of organizations that are divided in that we came from different horizons, like research institutions. We have 4 research institutions, 2 regional administrations, 2 NGOs, and we are working at 7 marine protected areas that they are set in different places with different environmental conditions and with the different socio-economical context. So this is for us is a really great opportunity because we join a really nice team that is making great efforts to do all these tasks that we plan for the project, and they are producing really nice results on the activities, and we are really confident that from the lessons learned from the implementation of all these activities, we can provide this common framework, or at least to contribute to this common framework that it's really required to face the climate change in the Mediterranean, as well in other parts of the Earth. Okay, so we are really happy with this, and we will be as well counting with the collaboration of 30 associated partners. That they are not just there, just putting their names in the project. What we did is organize them in 3 capitalization boards. We call this because we want them, since we have this aim to spread or transfer the results of the project. We wanted the other key actors involved already at the very beginning of the project, and then be able to spread the key messages and the key tools through the Mediterranean networks, and with the information of the different groups of scientists, research organizations that they are working on this. And of course, we have other marine protected areas that are not in the project, but they are willing, or they are already testing some of the tools that we are proposing, and this gives us more opportunities to see if the approaches that we are proposing, they are suited or not for the purposes. And I am at my last slide, and I wanted to stress or highlight the lemma or the motto that we came with MP Engage, which is it's a kind of a summary of our perspective or our approach on MP Engage project, which is act local and think Mediterranean. Thank you for your attention and for the opportunity of explaining just briefly as this, but explain what are our main activities on MP Engage. Thank you very much.
Thank you very much, Joaquin. We are moving to Theodora Paramana from the Department of Chemistry of the University of Athens. She will present the implementing marine spatial planning in Greece.
Good morning, everybody. Thank you for your invitation. I'm going to share my screen. Can you see it, please?
Yes, we can see.
Okay. So this presentation is from the policy perspective, and we're going to have a quick look on how MSP, Marine Spatial Planning, is related to climate change, and why its climate change should be considered in marine spatial planning. And then I'm going to shortly present the involvement of the ethnographic team of University of Athens in implementing marine spatial planning in Greece. There is a question, why do we need marine spatial planning in the first place? And as we have all noticed in these last years, there's a high and rapidly increasing demand for marine space for different purposes. The production of energy from renewable sources, oil and gas exploration and exploitation, maritime shipping and fishing activities, ecosystem and biodiversity conservation, extraction of raw materials, tourism, aquaculture installations, and underwater cultural heritage. These multiple activities and uses create multiple pressures on coastal and marine resources, and also lead to conflicts among the different uses, what we call user-user conflicts, as well as conflicts between human uses and the marine environment, the user-environment conflicts. Therefore, there is urgent need to manage spatially and temporally the distribution of human activities, as well as need for integrated planning and management. How do we define marine spatial planning? MSP, in other words, is a public process of analyzing and allocating the spatial and temporal distribution of human activities in the marine areas in order to achieve ecological, economic, and social objectives that are usually specified through a political process. And in order to have an effective MSP, this should be ecosystem-based, it should be integrated across sectors and agencies, that is among levels of governance. It should be localized, it should be adaptive, learning from experience and implementation. It should have a strategic and anticipatory nature, and finally be participatory, thus involve all interesting stakeholders. According to United Nations, there are certain, MSP is a really structured process involving 10 steps for its development and implementation. There is need to identify, it has to identify the need and establish authority, obtain financial support, organize the process through pre-planning, organize stakeholder participation, define and analyze existing conditions as well as future conditions, prepare and approve the spatial management plan, implement it and enforce this spatial plan, monitor and evaluate its performance, and of course, adapt the marine spatial management process. MSP has been characterized as a cross-sectoral, forms one of the cross-sectoral tools supporting the implementation of the EU integrated maritime policy. It is a practical way to create and establish a more rational organization of the use of marine space. Is a process which is according to which the relevant member state authorities analyze and organize human activities in order to achieve their objectives. And as we said, an effective MSP has to manage to resolve conflicts among maritime uses and between uses and the marine environment, and provide opportunity to address the cumulative effects of the uses. And when it comes to climate change and MSP, MSP should, must effectively integrate climate change as the acceleration of global warming and increased vulnerability of marine social ecological systems affect the benefits provided by the ocean. Therefore, aspects of climate change have to be taken into account during the various MSP processes. First of all, there is direct impact of climate change on the seas, as well as opportunities and restrictions deriving from it. For the humankind in the use of marine and ocean resources. There are indirect connections to marine spatial planning, since climate change effect can directly and indirectly impact marine ecosystems and related biological resources. There are demands on the use of marine areas for the production of various forms of fossil-free energy, offshore wind and wave power, and which is expected to increase mitigation targets. Mitigation of climate change may also involve changing transport patterns. And then from a climate change adaptation perspective, there may be demands that need to be considered, such as coastal erosion adaptation measures, and of course, regional and national policies for ocean planning, as well as individual processes, legislative, for example, need to be effectively incorporated. So in order to tackle all and reflect all the previous set issues, in 2014, the Maritime Special Planning Directive was introduced in order to plan and regulate the human uses as well as protect marine ecosystems with a view to sustainable growth, maritime economies. And it forms a cross-cutting policy implementation tool, trying to enable a coordinated, integrated, and transboundary approach. According to the requirements of this directive, by the end of March 2021, all EU member states need to have their marine spatial plans drawn and have identified all existing activities in their waters and an effective way to manage all existing activities, taking into consideration land-sea interactions and considering cross-border cooperation. In this effort, member states need to apply the ecosystem-based approach and align fully with the Marine Strategy Framework Directive. MSPD, the directive concerning MSP, has been transposed into Greek law with Law 4546 in 2018. Talking about the Marine Strategy Framework Directive, it is the umbrella directive that characterizes the marine environment at this point. We are in the second circle of the directive, where member states are trying to readapt to the efforts they have made since 2012 to assess the status of their marine waters, to monitor the status, to introduce programs of measures in order to achieve good environmental status by 2020. And as you can see, previous speakers have mentioned the Marine Strategy Framework Directive. There are, everybody has to follow these 11 descriptors characterizing different components of the marine environment, diversity, biological diversity, non-indigenous species, fish, food webs, eutrophication, seafloor integrity, alteration of hydrographical conditions, contamination, and energy and noise. Moving on to the implementation of marine spatial planning in Greece from the environmental perspective. Here is a slide on the work produced in the framework of Supreme Project, an EU-funded project which ran in 2017-2018, having 5 different East Mediterranean case studies developed, and different various, as you can see, Italy, Croatia, Slovenia, and Greece, various Mediterranean EU countries involved as partners. This project tried to establish cross-border coordination and also tried to introduce MSP issues in the Eastern Mediterranean, provide methodological approach to applying MSP. Here is a matrix on, let me tell you that it followed the Marine Strategy Framework Directive in order to approach the marine environment and have a full understanding of it in order to structure the MSP process. Here's a matrix of conflicts and synergies in the use of maritime space, the different maritime sectors, professional fishery, recreational fishery, aquaculture, maritime transport, energy, coastal maritime tourism, and their conflicts and synergy. Dark colors show higher conflicts, lighter color shows no conflict or very low conflict. Moving on to another work produced by the University of Athens related to MSP. This work was initiated in Supreme project and was produced after the completion of the project. It was presented last year in Turkey. The scope of it was to define the status of the environmental status of Laconicos Gulf in order to inform the steps of the planning process. And therefore, the work entailed collection and mapping of existing information on biological and ecological components, on oceanographic and other physical environmental parameters, spatial and temporal information about human activities and associated pressures. And the development of a geodatabase took place, and the outputs were maps of the interrelation of the above features, showing the current status and pressures of the area. I won't say much about Laconicos Gulf. Here is a short fish about the Gulf. It is a semi-enclosed embayment in the southern Peloponnese, Greece. And here you can see a map involving bathymetry, coastal geomorphology, hydrography, water circulation, coastal erosion, and vulnerability to potential sea level rise. Concerning the living resources, Laconicos Gulf and the Kythera Island involve important ecosystems of high biodiversity with numerous species of community interest present. However, we have large knowledge gaps concerning the biology and ecology of many marine species, and there is also limited data about the status and trends of highly variable habitats. The living resources, continuing on living resources, when it comes to species, we found there are several macroalgae, cetaceans, reptiles, fish, invertebrates, and seabirds. Concerning habitats, the most common of them are Posidonia oceanica medias, coralligenous formations, and marine caves, whereas there are Natura 2000 sites, areas of special protection, and areas of conservation. When it came to non-living resources, we found that there's no exploitation of marine aggregates taking place in the area, at least not official information about it. Whereas concerning oil and gas reservoirs, I think you also know that the area is under investigation, and the offshore of the study area has been included in the areas to be licensed for exploration and exploitation of hydrocarbons, as you can see in this map. Concerning the human pressures on the marine environment of the area, we found out that following the Bathing Water Directive concerning microbial pathogens, the approximately 40 points of bathing water quality measuring. The quality is excellent of the water, and also we focused on the wastewater treatment plants in the area, and we saw how their contribution in the to the marine environment according to the input load, to the daily input load in BOD. We also examined the heavy metal concentrations in the area, which were not high, as the anthropogenic activities are not especially high in the area. So the concentrations remain low, whereas concerning litter pollution, it is found as moderate. And generally, it was noticed that land-based sources mainly contribute to litter items. Concerning eutrophication and the nutrient point and diffuse sources in the area showed good and moderate eutrophication biological status and the general integrated status in the area good or moderate. Overall, the anthropogenic activities taking place on the coast create land-sea interactions. However, they are not of high intensity, as there is not intense industrial and tourist activity, neither especially big urban agglomerations. The only, we could say, intense activity is that of oil mills associated with olive oil production. And the final slide concerning the human pressures on the coastal and marine environment of the area concerned the living resources exploitation, and a sector which is not developed and will probably remain undeveloped in the future, as the area is not among the priority areas for cultural development. And generally, there is fishing activity in the area, with major threats being overfishing, illegal fisheries, NIS, pollution, and degradation of natural habitats and climate change. So, in fact, the general reasons, the general factors for threatening fishing living resources exploitation. And one final aspect concerned NIS, which forms a considerable biological pressure in the area and on commercially exploited species, with many invasive species sighted in the area. Overall, we can say that the coastal and marine environment of Laconicos Gulf is fairly influenced by human-induced pressures. Approaching the area of Laconicos Gulf, we reached some conclusions and made recommendations concerning, in order to inform the MSP process. As mentioned, the area is an important one concerning biodiversity, with important ecosystems and high biodiversity. The whole Laconicos Gulf is in good environmental status concerning contaminants and eutrophication. Although there's not a satisfactory registry of input loads, land uses do not seem to impact significantly the marine environment. Land-derived litter constitutes a problem. So land-based activities should be monitored and controlled in order to reduce the amount of litter introduced in the environment. The important ecosystems which are protected by Natura 2000 should remain in this protection regime. And as Lacanicos Gulf is not especially developed, and there are activities which do not take place in the area, we assess that it should remain as it is in order to have an ecosystem-based approach. And given the fact that good environmental status should remain as it is, all the uses and activities that will degrade the environment should not be allowed. And this final slide shows the state in marine spatial planning implementation in Greece at the moment. Greece has not produced an official adopted national plan, marine spatial plan, although we are just a few months before the threshold as introduced by the directive, the deadline, I should say, which is March 2021. However, at this point, there are sectorial special frameworks for spatial planning for aquaculture, tourism, industry, and renewable energy, which provide, which have provisions for the coastal and marine sectors. However, the state is, and the Directorate General of the Ministry of Environment responsible for marine spatial planning in Greece is in a process of trying to implement the directive as fully as possible, and so therefore their partners in MSP Med project, which was recently initiated and will have a duration of 2 years in order to support the implementation process and in order to promote the collaboration among Mediterranean countries, and also participate in a Greece-Cyprus Interreg project, THALHOR, which intends, among others, to formulate the first phase of a national spatial planning strategy for marine space and provide a maritime spatial plan for a specific insular area as it has been designed. So that is all from me. Thank you for your attention, and I'll be glad to answer any questions.
Thank you, Theodora. We don't have time for questions here. Probably at the end, we can discuss issues that have emerged. We move to Emmanuel Lavakis, also from the Department of Chemistry of the University of Athens, development of a method for the evaluation of the management of marine protected areas, application to 2 Hellenic marine protected areas. Please, Manos, share your screen. Manos, can you hear us? Manos?
Έλα, ναι.
Okay, you can share your screen now. Oh.
Okay, I'll share it. Well, I'm ready to begin. Do you hear me?
Perfect. Yes, I can hear you. Please. Oh, please lower your the volume.
I have to mute it.
The sound, probably because it. No, I believe it's okay now.
It's okay now?
Yes, yes. Maximize the presentation. Please start.
Okay. Good afternoon from me. My work is presents the development of an assessment algorithm for the management of marine protected areas. in order to make possible the objective evaluation of the effectiveness of their operation, and to facilitate the comparison between similar protected areas as well as the decision, measure, and action taken towards management improvement. The algorithm is adapted to the environmental condition prevailing in the Mediterranean Sea, while the features of the European Union Framework Directive 2008 for the marine strategies, MSDF, were taken into account, as well as it was also taken into account the sustainable development model as determined during the Thessaloniki Convention in 2007, organized by UNESCO. A brief description of the algorithm. This algorithm involves recording of the environmental conditions, recording of residents and tourist public opinion, recording of the operators' aspects through interviews with the representatives, and information gathered from a variety of sources. It also needs the filling out of specially adapted assessment sheets. That means scorecards, specially created for this purpose, and the end product is the ratio of their performance to an optimal one as resulted by respective evaluation sheets. The exporter ratios are used to calculate the output management coefficient according to a mathematical type that must be as simple as possible, but not simpler. Concerning the environmental protection, the initial approach was the protection of the threatened species, but this was not enough, it was inadequate, and the next approach was the protection of the whole habitat of threatened species. But the modern perception is that it's the achievement of a sustainable development, so that the existence of an MPA affects culturally and economically the local society. It can also positively contribute to the education, especially environmental education, and to scientific research. The sustainable development is based on three pillars: economy, society, and environment, as you can see in this figure here. And the European Union added a platform that the pillars must stand, that symbolize the environmental education. The sustainable development includes the establishment of a white zone, more or less strictly guarded or regulated. That means that it needs to establish industrial areas, urban areas, and protected areas, categorized according to the way they are managed, that you can see in this small table here. In the Mediterranean Sea, there are many marine protected areas. Most of them are managed or have an equal management protocol. In Greece, there are 5 marine protected areas, but the most important of them are the National Marine Park of Alonissos in North Sporades, that is the second biggest, widest in the Mediterranean Sea, and the National Marine Park of Zakynthos. In those 2 marine protected areas, we applied our methodology for the evaluation of the management of marine protected areas. As description of the algorithm, now it consists of 4 steps. The first step includes society, economy, and education, and we work only as being only one parameter. That means that it's one parameter with 3 sub-parameters. Second one is the environment. Second parameter. The third parameter is the influence of the environmental, of the management operator, of the management body to the society, to the local society and economy. Second step is recording the social and environmental parameters in with a variety of ways. And the third one is the evaluation of social and environmental parameters using the collected data from questionnaires and the determinations and the measurements and all that. The fourth step is characterization after calculating factors that are input for a formula, for a mathematical formula that with the help of which we extract a benefit factor. And then this benefit factor is we use an evaluation table in order to extract the final results, the final conclusions. Concerning the collection information for concerning the social parameters, that includes design, distribution, evaluation of questionnaires for residents and tourists, different questionnaires for residents and tourists, visit to the study area to form one's own perception in parallel with the collection of samplings and unsat measurements, and collection of relative information from a variety of sources, including the internet, bibliography, the national nomenclature, etc. The response, we collected about 350 questionnaires from the residents and tourists, and those questions were distributed into 4 groups. First group is the profile of the respondent we need that for statistical reasons. Second is the contribution of the MPA to their life and their activities. The third group is about what do they think about the performance of the MPA, and then the fourth group, what do they think about their own sensitivity, environmental sensitivity. Antinomies and contradictions were detected on those questionnaires. Anyway, the collection information that concerning the operator includes the filling of an appropriate questionnaire from a representative of the management operation and an interview that was also carried out. The questionnaire contained 41 questions divided into 5 groups, as you can see here. We're not going to analyze them, not enough time for that. And but we can say that the answers were taken into account in completing the scorecard. The code of the environment on the status includes the planning of a sampling network, methodology of samplings, measurements, and determination at the laboratory. The Marine Park of Alonsos has a network of 17 points, sampling points, while the MPA of Zakynthos has a network of 15 sampling points. We have to say that the sampling point network was a compromise of the representativeness of the each area, the technical possibilities and facilities that are available in our laboratory, and the restriction imposed by the regulations. The chemical parameters determined are as shown in this table. There are parameters determining water, sediment, and tissue samples. For sediment tissue samples, we were most determined a series of metals. The most important one for the environmental aspect. Concerning the measurements, the in situ measurements, that includes the pH, the pH, the salinity, the surface temperature, and the dissolved oxygen. The aim of the algorithm inter alias is the achievement of a balance between environment and society. Because in a managed protected area, we think that the environmental situation and management objectives should be in a balance and harmony with the social and economic development attributed to the existence of the MPA. The main mission of the managing authority, of the managing body, is to ensure that a balanced and sustainable social development is maintained, which will ensure that the degradation of the environment is minimized. Of course, we can say that a zero degradation of the environment happens only in virgin areas and not in the habitat areas. The social parameters and the environmental ones are depicted as the sides of a regular triangular pyramid that their faces symbolize the parity, as we can see here. And then there are 4 sides equally one to each other, and the management authority, the managing authority, the manager body, is as a regulating factor, is depicted as a sphere that surrounds this pyramid. The valuation, now we need try to explain to how the algorithm was developed. The valuation of each parameter is based on relevant scorecards. That means that there are graded questionnaires which are designed for this purpose. The end product is a ratio of their performance to an optimal possible performance as resulted by the scorecards. There are 3 scorecards, one for the social parameters, that means social development and admittance, society, educational research and research, that's the education, and economic development, that's the economy, composed, that those 3 parameters, those 3 sub-parameters compose the social parameter, and is evaluated at the first scorecard. The second scorecard evaluates the quality of the environment, and the third one evaluates the influence of the management authority to the local community. How to evaluate the social factor? There are, as I said, 3 sub-parameters for the social parameter: development, social development, education, and quality of life and economic development. The questions of the scorecard are as presented here, and we can put a weighting coefficient. We can define the weighting coefficient for each subparameter, by which the total score of each parameter is multiplied and the final score is obtained. We have the limitations is that the sum of the coefficients must be equal to their number. That means that the sum of the weighting coefficient for those 3 subparameters must be 3, because we have 3 subparameters. Of course, we can put weighting coefficient for the groups or also for the questions, but that makes the algorithm too complicated and too time-consuming. Each group of questions is graded, and the ratio L of the score to the maximum score is calculated, and we put a bonus of +1 if the L is exceeds 0.75, or a malus of -1 if the L is less than 0.25. The sum of the score of all question group of which for each social parameter gives us the total score. And here is an equation that calculates the total score. And in the right side of your screen, you can see an algorithm used for this for calculating the total score, which is divided in 3 modules, module 1, 2, and 3, that are algorithms. The shape of algorithms quite more complicated, no time to explain them. After that, we can discuss about results of the social factors calculated for the social parameter. When in one scenario, many scenarios were used, but I represent here 2 scenarios only. First scenario is when its weighting operator equals to 1, so the performance for the society, education, and economy for the social parameters is 47.3% for Alonso's and 57.4% to Jackson. That means that the benefit to the society is that percentage. Using another scenario where the weighting operator for society, education, and economy is 0.6, 1.1, and 1.3 respectively. So we have other results, different results. You have to notice that the sum of the weighting operators equals to 3. 0.6 plus 1.1 plus 1.3 equals to 3. And in this scenario, the benefit are more. That means that we give more attention to economy rather than to society and education. How do we evaluate the management authorities factor? It's we extract it by the field of the appropriate question by the representative and the interview. The evaluation is based on a relevant evaluation sheet developed by the relevant department of the World Bank. The performance expressed as a percentage of the optimum performance, but we have to pay attention here that a very high percentage of this management agency's contribution to this balance is as undesirable as the very low percentage, because a very high percentage means that the operator has too much influence on society, and a very low percentage means that the agency has a sufficient effect that means that it doesn't work well. The results are 50 to 60% for Alonso's and Zakynthos respectively. So we find the second parameter, the second factor, and now how do we find the third factor, that is the evaluation of the environmental quality. We used the parameters mentioned in the MSDF. That means 11 features mentioned before from other speakers, from my previous speakers also. And the results, we have to mention that in a total of 81 questions designed, only 53 were answered, or 65%. This is a problem. You can see here the results don't stay in so many numbers, but see at the right down corner the final performance, that is 87% for Alonso's and 85% for Zakynthos, meaning that this is the percentage of maintenance of the environmental maintenance, or that the degradation is 13% for Alonso's and 15% for Zakynthos. Zero degradation is only virgin areas, as I showed before. Now, the composite equation, that is a function of the three factors just calculated. The proposed equation after many attempts is this one, where the benefit factor, this is the benefit factor, where 1 minus n describes the environmental degradation, or n is the environmental conservation, 85% for the case of Zakynthos, and 1 plus f describes the influence of the management operator, and k describes the effect of the MPAs in the local society. But in order to evaluate well the situation, we need to have an evaluation table. You have to construct it, this table. And in order to construct it, we use diagrams of the variation of BF of benefit factor against the other three parameters. As we have 4 parameters, environment, operators, influence, and social development, and the benefit factor, we probably need a diagram of 4 dimensions, but this is not, we cannot do that. It's not possible. So we keep 2 of them constant, and we make diagram of the benefit factor against the social development for different values of environmental degradation and different values of operators influence. After having studied a good number of diagrams, we proposed this rating scale. At last, the final result is that the Alonso's has a benefit factor of 5.4 and Zakynthos a benefit factor of 6.1. That categorize both MPAs in the adequate level, but it is desirable to make some efforts to be improved. Finally, last slide, the advantages and the disadvantages of the algorithm. Concerning the advantages, we can say that it's simple, it is adaptable, it creates added value derived for the collection of many information that could be used in the other projects. It is adapted to the framework MSDF. It takes into account all stakeholders of the local society, as well as the residents and the tourists. That's very important. And it has the ability to evolve and improve in parallel with technological and management improvements. The advantages that we could detect it is that the step of the data collection is time consuming in the hard coding. And there is often a lack of data specifically on environmental assessment, so that some of the parameters of the case of the framework directive remained unanswered. You can remember that from the 81 question, only 53 were answered. And of course, the subjectivity of the evaluator who completes the evaluation booklets. Thank you for your attention.
Thank you very much, Manos. A small question from us. Please lower your microphone or something. Okay. A question from the chat. Kostas IEF asks if somebody can have access to the scoreboards and the survey materials that have been used for this project.
Could you repeat, please?
If somebody has access to the scoreboards and survey materials that have been used for this project.
Yes, if someone wants to send you the scorecards and the scorecards and the evaluated numbers, yes, I can do it.
Okay, so you can speak privately in the chat.
Okay, yes.
Thank you very much, Manos. Moving on to the fourth session of the day, field data collection, we will start with Professor Paraskevino Mikou from the Faculty of Geology and Environment at the University of Athens, state-of-the-art marine technologies for sea floor mapping and virtual underwater experiences.
Okay,
Evie,
thanks.
please.
Yeah, I can share my screen. Okay, can you see now?
Yes.
Yeah, slideshow. Just give me 1 minute for the slideshow.
Mm-hmm.
Okay, so thank you everybody for this very interesting web conference. Unfortunately, due to the COVID situation, we cannot meet each other, so we can use the Zoom meeting for these very interesting conferences. So I'm going to talk about how we map some specific areas and how we use state-of-the-art marine technologies for seafloor mapping, that they are very, very useful for the shallow, especially for the shallow environmental cases. And of course, I'm going to present some first results for the virtual underwater experiences that we have established under the framework of Virtual Diver. It's a project, it's a Greek project. So for the seafloor exploration, you all know that we use the oceanographic vessels. To the left, there is a Greek vessel of Aegeo, of HCMR, but also we use high state-of-the-art marine technologies like AUVs and ROVs in order to collect data and map the seafloor. And also, of course, we use different kind of equipments. And the most important thing is that sometimes when you are on board, you have the chance to broadcast, okay, to send the data online and also to chat with other colleagues and especially with students. So it's a very special sport in a way, the oceanography, but it's very, very expensive because you need to have a lot of money in order to rent equipment and of course the vessels. So why do we need to map the seafloor topography? Because for us, for the oceanographers, it's very crucial to identify the different geomorphological features. And if we are talking about the marine protected areas, we will be focused in the continental shelf or sometimes some part of the continental slope if we are very close to land. And there are lots of canyons and many other geomorphological features. So we map the seafloor in order to indicate the different geomorphological features and also to study the geodynamic of the area. The other reason that we need to map the seafloor topography is to identify the marine geohazards. And for us, marine geohazard means that we want to map the active fault zones that can give a lot of earthquakes, Of course, the submarine volcanic eruptions and the submarine landslides that they can produce catastrophe, especially in the coastal zone. This is very interesting scheme that can identify all from Kyoto et al. 2011 that can see all the different marine geohazards in one only slide. Okay, so what we are doing, there are three different methods how we can collect seafloor swath data in general. We may use satellite altimetry in order to produce huge bathymetric maps, but with a resolution, the spatial resolution 1 kilometer, the grid cell. Most of the time we use the multi-beam sonars, okay, but with a resolution 25 up to 100 meters. The best is to have a resolution of 20 or 10 meters, but the best technique is to use underwater vehicles, the AUVs, that they can go very close to the seafloor and they can map the seafloor with a resolution of less than 1 meter. Sometimes we have the resolution of 1 centimeter. So this is a video how we map the seafloor using multi-beam systems. And for sure, the different ways of the seafloor mapping give you different results of the seafloor topography. So the multi-beam systems, this is very nice scheme, emits sound waves, okay, in a fan shape beneath a ship's hull, and the amount of time it takes for the sound waves to bounce off the seabed and return to a receiver is used to determine water depth. So it's very fascinating for all of us that we are on board, just because in front of a wide screen, when we have the swath survey, just in front of you, there is the design of a very beautiful bathymetric map. And of course, you may need different types of the multi-beam echo sounders, and that depends of the data that you want to achieve, and also what about the purpose of the surveys. So we have different multi-beam echo sounders with different frequencies, the operational depth, the swath width, and the horizontal and vertical resolution. But of course, just keep in mind that if you need to map in larger depth, you will have a larger angle, so the data, they don't have so good resolution, and the big footprint, that means the less resolution that you will take. So this is a map. As you can see, there are lots of parts of the ocean floor that have never been mapped. Fortunately, only 8% of the seafloor, but fortunately there is a new project, with a national project named as GEMCO 2030. So there are lots of private companies and also public companies, public institutes, for example, that they gave money to research institutes to map the seafloor and collect data for the topography reasons. So this is that means that the vast expanses of the seafloor, which covers roughly 70% of the planet, remain virtually uncharted. You can see that hopefully in the Mediterranean Sea, most of the parts of the Med Sea, especially in the Eastern Mediterranean, they have been mapped. So the data that have been released for the Europe, for the Mediterranean in general, and also around UK and Scandinavian countries, is the EMODNet. This is a platform that you can give your request. You can submit your application form and you can take the data, but with a resolution of 125. This is very important. This platform, this digital platform, is very important because you can have any kind of data, physical or chemical data, and of course biological data. And the other reason that we may use, and you can use the EMODNet data in the marine protected areas, is that they have lots of data for the habitat mapping around Mediterranean Sea. So the satellite altimeters measure sea surface height and other characteristics of the ocean surface, which are linked to underlying processes and structure. This makes the data useful for understanding the full depth of the global ocean from the surface down to the seafloor, but you don't have the resolution that you need if you want to study the microbathymetry, or if you need to study a specific part of the seafloor topography. The grid resolution, as I said before, is approximately 1 kilometers. And to tell you the truth, this is a comparison to above, okay, to the upper part is a map in a specific area with a resolution very close to Galapagos Island, with a resolution of almost 1 kilometer. And to the bottom, this image shows exactly the same area, but they had collected data, the SWEF data, with a resolution of 10 meters. And so you can see very clearly all the mounds, the sea mounds, or the volcanics, the domes, the volcanic domes that they are presented in this area. So everything depends to the resolution that you want to have from the cruise. And of course, with the SWAF data, you can identify all the marine geohazards. This is an example of the SWAF topographic map of Santorini. And in Santorini is a supermarket of natural hazards, as you can identify on the seafloor, huge active fault zones like the Amorgos fault zone that has been activated in 1956 and gives the most destructive earthquake in Greece. All different volcanic domes, this is Colombo volcano, or some other areas that gives you lots of submarine landslides. So we map crucial areas like Santorini in order to identify and characterize the marine geohazards. What else we can do? We can merge the onshore and the offshore data, like for the Google Earth. Okay, and that's why, and then you will have a combined topographic synthetic map. So you can drain the ocean, okay, and you can follow, for example, from the top of the mountain, you can follow a canyon up to the depth of the biggest basin. Okay, but the most impressive marine technology for mapping the seafloor is the AUV, the autonomous underwater vehicles, are unmanned robotic craft, which can autonomously survey the ocean floor along the pre-programmed course. The only thing that you need is that you need to have a group of very specialized technicians, and they can program the route that you want to map, and you can leave the AUV for approximately 12 hours, okay, to map the seafloor. So the AUV can reach the seafloor very, very close and have a grid cell of, as I told you before, less than 1 meter, approximately 30 meters. This is one of the AUV that we used in the Atlantic Ocean, EBIS from Geomar. We map one part of the mid-ocean ridge, and this is another AUV from the University of Girona. This AUV's the operational depth is almost 500 meters, but ABIS can go up to 3,500 meters. So as you can see to the right, this is the route that the technicians gives, of course, in agreement with the scientists, for the AUV to map the seafloor. But you can easily understand that if you have this kind of marine technology, you can map a specific area of the seafloor and not a broader area. And this is an example of the axial sea mound in the Pacific Ocean to the left. Okay, you can see the SWAF data, the SWAF bathymetry map with a resolution of almost 20 meters, 20 to 25 meters. And then you have the resolution of the 1 meter using the AUV. So we are using this kind of state-of-the-art technology like AUV in order to study the microbathymetry, all the very small geomorphological features. What else you can do with AUV, and this is very, very important for mapping the marine protected areas, you can have different kind of sensors, okay, like geophysical instruments, for example, or geochemical instruments, and you can create photomosaics and, of course, identify the different texture, the different types of textures of the seafloor. But, okay, so the AUV is used for the Atlantic or the Pacific or the Aegean Sea in order to map the seafloor, but the crucial point also for these case studies of marine protected areas is to map the coastal zone. So you need to merge the onshore, the near shore, and the offshore data, okay, in order to have a synthetic, a combined map. So most of the time we used urban lidar bathymetry and satellite derived bathymetry, but this is very, very expensive, okay, in order to have this kind of data. And then you can use drones, like the one that we use the southern part of Milos, and have specific sensors, and you can collect data like the one to the right. You can collect data of the coastal zone. But the near shore elevation data, you need to have very good water column quality. This is the most significant limitation for the drone surveys. You need to have, you need to define the different type of coast. So it's very difficult. For example, it's completely different to map a coastal zone with a delta or a coastal zone with rocks, or a coastal zone that they have lots of habitats or posidonias and whatever. So the near shore zone must be gently sloping and not too steep. Okay, so there are some limitations, some restrictions. The water transparency must be high. The significant water movements must be without waves. Okay, most of the times in the GNC we have too much waves, and no sun reflection of the sea surface. So when we are mapping the coastal zone, most of the time we are doing the drone survey with the specific sensors early in the morning or late in the afternoon, in order to have results like these maps. Okay, so you can create a synthetic photo mosaic, and also you can have a topographic synthetic map of the coastal zone, having onshore and offshore data in one map. But what else we are used? We used the underwater photogrammetry. Okay, the underwater 3D reconstruction techniques such as photogrammetry are among the latest of these advancements, which has primarily been utilized for seafloor habitat characterization, bathymetry mapping, marine environment inspection, and of course, archaeological surveys. So especially for the marine protected areas, you need to define the different types of plants, okay, and of course the different type of rocks, and that's why you need to use this kind of equipment, like this one, like Sparrows. It's a AUV, it's a small AUV, but you can use this AUV in a shallow water up to 200 meters, and you can use this AUV without the use of a huge oceanographic vessels. As you can see, for example, we used AUV in order to map this AUV Sparrows, in order to map the hydrothermal vent field at the southern part of Milos in Paleochori. That was very, very exciting because we did define the different types of bacterial maps. So we did the habitat mapping of the area. Now we are working on the manuscript, and you can have this AUV without the zodiac, without nothing, just put it on the water, program the different transects of the AUV, and leave it to do the work for you. Okay, but of course, this kind of equipment, they can map the seafloor in specific conditions, like this one, very good weather, and of course, only small part of the area that you want to explore. Otherwise, you need to stay there for many, many hours and days. What else? So we used ROV mapping. Okay, you can have different types of videos or pictures. For example, in our department, in the Laboratory of Physical Geography, we have a small ROV named as Jason. This is a Blue Rock 2. So you need only a small zodiac, or you don't need a zodiac for this. Okay, and you can map the seafloor using this transects, for example, like the drone survey, in order to collect videos and also photos, and create, of course, photo mosaic of the area. That was a video from our try to reconstruct the caldera, the Santorini's caldera seafloor. And I think that I need to reduce the voice. Okay, so you can see all the technical of this Blue ROV that we use in Erasmus project, and this is the application. So on this Erasmus Summer Cruise, we use the ROV without any zodiac, so we put it on the water from the coast. It has been connected with the cable, and then we have also the drone survey in order to map in very detail the coastal zone, onshore and offshore. As you can see, the survey area was very close to the coastline. So it's portable. You don't need to spend lots of money for rating a zodiac or a vessel. And you can create a photo mosaic. You have a real-time view of the seafloor. Now we have both lots of different multispectral cameras and different type of sensors for the habitat mapping of the coastal zone, and we will test them in the next few days, if the weather permits us. So this is the workflow, okay? And you can create the grid, then the point cloud. This is how we are doing the photo scan workflow and create a photo mosaic of the area. And of course, this kind of equipment, we use that in marine geoarchaeology. We have a huge archaeological project, marine archaeological project under the framework of UNESCO in Aegina, that we are mapping the ancient harbor of Aegina, and we use this kind of equipment. And except of this very light ROVs, we may use this ROV for deepest parts, for example, in Santorini caldera, in order to map the seafloor and of course to take lots of samples. But renting this type of equipment, you need lots of money. So we use this ROV from Guiomar in order to map the vertical cliffs of the caldera and create this type of photomosaics in a very high resolution. And of course, you may use the ROV and install a multi-beam system with high resolution. This is on the vent field. This is the photomosaic of the vent field of Colombo volcano. So you can have different types of cameras and take thousands, millions of photos to create the photomosaics, or you can use specific multi-beam systems to create this WAF map with a resolution of less than 1 meter. So this is the type, as we don't have a lot of time, this is the type of equipment that we use in order to map the seafloor. And most important thing is to use different type of sensors, okay, and cameras to produce photomosaics and also to produce high resolution bathymetric maps. What else we are doing? We have established a digital platform named as Virtual Diver. This is a very innovative platform, okay, in order to show the underwater world using virtual reality. So the scope of this Virtual Diver, of this innovative platform, is that the development of very innovative product from different specialized services, especially in tourism, but also you can use this type of product, for example, in order to show how is the submerged port, or how is the marine protected areas in Santorini or in Alonissos or in Zakynthos. Okay, and of course, we have developed a mapping methodology and 3D visualization of the underwater area. This is the overall structure of the developed Virtual Diver framework, has been provided of the project consortium. We are in cooperation with different companies that they know how to produce virtual reality, how with the cutting edge of virtual reality and VR. We use UNIS as a software. And of course, this kind of platforms, it will raise the values of the platforms clients like municipalities, ministers, cultural institutes, and so on. This is the different types of clients. And of course, the caption of the three world, the real three world of the visualization is the mapping technology. So first is the methodology, the system of heterogeneous bathymetric, visual, and multispectral data. So we have collected different types of data from onshore and also from offshore. It has an innovative structure for motion approaches that compensate the refraction in underwater image creation of 3D reconstruction. So except of the data that we have collected, we need to do the 3D models of the area, underwater and also onshore. We combine different processing techniques. We use different kinds of algorithms, and of course, the classification of the different multispectral data. So this is the type, for example, this is a drone survey of IA. So we use this kind of data for the digital platform. So as you can see, this platform is also for the onshore and the offshore with a very high resolution analysis. We don't have so much time, so I can avoid. And as I said before, we combined in the digital platform captured by drone the ROVs using specific software like Colmap or Mushroom. We process the data and we combine with custom algorithms. So for the end users, they can see in a way they can fly, for example, in Santorini, because the case stand is Santorini, they can fly from the top of the mountain and then they can dive in the bottom of the caldera, of the Santorini's caldera in one way. So this is the data that we used, the bathymetric data, the LiDAR data, and the CTM data. And of course, it's being developed using the 3D technology, one of the most widespread platforms for design, development, and implementation of interactive 3D environments. So the management, so we try to manage the 3D terrains with the relevant metadata and the implementation of narrative scenarios, because all of the transects that we use from the onshore to the offshore, they have specific scenarios. This is the, for example, the components that this platform is going to be used. Like we have a lot of images, videos, audio players, some persons that they can tell a story, or the panorama or 360 videos or 360 photos. This is the user interface design. I'm not going to read all this type of data. And of course, this kind of platforms can be used by tablets or smartphones, by the VR headset, Oculus. In our laboratory, we have already established a small classroom with 2 Oculus and different types of 3D models in order the students to study the geology and of course the geomorphology of the offshore and also on the onshore environment. Okay, and for example, for the last slide is that all this type of digital platforms will promote technical and financial constraints of the creation of virtual experiences, because it's very hard to participate and it's very difficult to participate in oceanographic cruise. And of course, if you need to have the data, you need to show to the data to the students or to the other people, and to show them how beautiful and how magic is the underwater world. The virtual diver interaction platform will simplify the process of implementing the integrated virtual experience, the scenarios that we have already produced, the audiovisual productions we have, because we have different types of interviews from different people of different disciplines, and of course educational material. Okay, we'll address private or non-operators with an innovative B2B service in order to boost their commercial value. And of course, we'll establish a new approach, then this is very important, to promoting the cultural and environmental supply. So you can use this type of digital platforms for geological purposes, for archaeological purposes, and of course for environmental issues like a marine protected area, to show in a better way how beautiful is the underwater world. Thank you so much.
Thank you very much, Evie. We're moving to Medaset and Vicky Ray. She will present the exploration of potential nesting sites and design of conservation measures for sporadic nesting in Albania during the period 2018 and 19. Vicky?
Hello.
Hello.
Okay. I'm here. Can you see my screen?
Yes, we can.
Okay, excellent.
Please maximize it and start.
Yeah. Okay, there we go. So, hello everyone. I'd like to firstly thank the organizers for giving us the opportunity to present our recent work in Albania. This project is funded by the MAVA Foundation under the Conservation of Marine Turtles in the Mediterranean Region program, and has 7 direct partners and additional indirect partners implementing activities around the Med. So our data collection in Albania took place during the nesting season of 2018 and 2019. We had 2 main activities, to monitor for nesting activity and to assess the suitability of the coastline to support viable nesting. And this second activity was our main focus for our data collection. So for physical characteristics of the beaches, we collected data on substrate type. We measured compaction to see if the beach was soft enough for a female to dig an egg chamber. We mapped elevation of suitable levels at 0.5 and 1 meter elevation. And we also collected temperatures for sand, which was part of a regional activity, which I'll go into detail in a moment. But we were given sand temperature loggers to place at certain beaches. And we also wanted to measure the seawater temperature of the inshore, as we wanted to know if and when the waters were warm enough to mature the eggs of the female, which threshold has been estimated to be for loggerheads of 20 degrees. The grey activities that you can see listed were Mediterranean-wide regional activities, and they were coordinated by our Turkish partner Dekmir, for which all of them we collected information from Albania. The sand temperature Dekmir has kindly shared with us, so I'll be able to go through some of that data later in this presentation. For the genetic studies and the isotope analysis, these are still being reviewed with all the other samples collected around the Mediterranean and hopefully will be published later this year. So looking at the suitability of the Albanian coastline, we started with a Google Earth search, identifying all possible sections along the Albanian coastline. Each section was entered into a database and given a code number, and in total 160 sections of coastline were identified, which directed our fieldwork. In the field, the survey was led by Dr. Enerit Setanaku, who unfortunately can't be with us today, but he was assisted by a team of students from Tirana University. So looking specifically at Vlora region, we identified 112 sections of coastline, and on field inspection, 93 of these sections, no further data was collected. Now there are various different reasons as to why. Some beaches we could not access, either due to they were part of the military zone, or you needed a boat to access them. Some beaches had extreme levels of tourism. Now, this is not to say that the physical characteristics of those beaches were not suitable or did not appear to be suitable for nesting. It was more due to the fact that spatial and time restraints of the research we had to do the survey meant that we decided our survey efforts were better concentrated in areas with which were less modified. And then the remaining sections that we surveyed were 19 along the Vlora region. So if the sediment type was deemed to be suitable for nesting, further data was collected. So for compaction, this was measured along a transit that was laid out by a tape measure from sea level to the back of the beach. And then measurements were taken using a compaction meter every 3 meters. The average of the depth reading that we collected were then used to categorize the compaction for the section that we were surveying into either high compaction, which was an average of 25 centimeters or less, medium 25 to 50, and low compaction was anything over 50. We considered compaction categories of medium and low as exhibiting suitable areas in which females would be able to dig an egg chamber. So for the purpose of this presentation, we've split the results into the southern region on the left, and on the right is the rest of the northern coastline that was surveyed. The dashed lines define the categories that I just explained on the previous slide. So for the compaction, as you can see, most of the results we got for the Vlora region fall within the medium range. And then the softer sediments with the softer compaction were found within the northern region. For elevation, we used 2 techniques. We used a theodolite along the transect, and we also used drone imagery as well. If the imagery collected by the drone was of good enough quality, then a spatial analysis would be carried out using the elevation tool in Drone Deploy software, which are the screenshots you can see in front of you. So to do this spatial analysis, first of all, the beach area was defined, which is the blue area you can see on the far left. And then we could draw transects at certain areas along the beach area, which would give us the elevation profile. And then along there, we could mark in the 0.5 elevation, which is the yellow, and then the 1 meter elevation, which is the red. We join those all up, and then we get an estimate of the spatial extent of the elevated levels. So looking at these spatial areas along the Albanian coastline, we can see in the north, in Derini Bay, there were quite a few beaches that exhibited high levels of elevation, but the majority of elevation was found in the southern region, in the Vlora region. So to provide an overall assessment of the beaches, we combine the scores for compaction and elevation levels to rank the suitability as either high, medium, or low. So the map on the left shows the entire coastline with the majority located in the south and in the north here, although to be fair, it is very mixed along the coast. Looking at Vlora in more detail, 19 sections were surveyed here. 9 were highly suitable, 8 were given medium suitability, and 2 low suitability in the middle here. And these 2, they failed on elevation levels. They did not have elevation levels of over 0.5 in the sections that we surveyed. So for monitoring of nesting activity, this was done by the survey team as they were in the field, but we were also assisted by some of the rapper rangers who provided observations and some monitoring along their protected areas for us. We also wanted to expand the spatial effort by involving the general public. So we placed posters along the coastline on how to spot a turtle track and the contact details of our lead surveyor. And also this had the added value of helping to raise awareness along the coastline. And then secondly, we also looked through the drone imagery for signs of turtle emergencies along the coast. So in our research, we did not record any nesting activity during 2018 or 2019. There was a nest that was laid in Divjaka during 2018, which was confirmed by HAS. And we were able to collect some data, which I want to share with you. I know it's technically out of the region, but just to highlight the importance of the Albanian sea turtle nests in terms of current times and concerns of population feminization. So this graph has been shared with us by Decamir, and it shows the sand temperature profile from a sand temperature logger placed within 1 meter of the nest. The nest was laid in mid-June and the hatch date was the 12th of August. So we can then calculate the second trimester period, which is the crucial period for determining the sex of the hatchlings. We use pivotal temperatures that have been estimated for the major Ionian nesting rookery in Greece at Kyparissia to give our 50-50 ratio, which is shown by the black dashed line there. So the average temperature recorded during this period was 28.15 degrees Celsius. So we can make the assumption that the majority of hatchlings that were produced from this nest were male. So highlighting the importance of these nests laid in cooler climates for supporting the male loggerhead population as a whole. So if we look at the temperature profile of the 2 beaches in Vlora region, firstly at Korez, which is in the southernmost point on the map there. overall, these were 1 degree higher than those recorded at Divjaka Beach. So we can conclude that these were suitable incubation temperatures. However, at Gipi, which is just north of Kerez, but south of Divjaka, we recorded much lower temperatures. Their average for July was 26.6 degrees. One explanation for this lower temperature profile is due to the albedo of the sand. The survey team recorded that the color of the sand was white. So this will naturally lower the temperature. Incubation rates as low as 27 have been shown to reduce the locomotive ability and survivorship of hatchlings. So although the incubation rates that occur at Gipi, it is most likely that, that hatchling success will be reduced at these temperatures. So lastly, we wanted to look at the water temperature and to see if and when seawater temperatures reached the 20 degrees threshold and if it was maintained throughout the whole of the nesting season. So we placed 3 aqualoggers, one in the north, in the northern part of Dirini Bay, one in the midsection of Albania, which was off the coast of Divjaka, and then one in the south, which was in the vicinity of Bruneck. The northern loggers were placed with the assistance of local fishers on their stavik nets, and the logger in the south at Bruneck was placed off the jetty. They were all approximately in 5 meters depth of water, and the loggers themselves were 1 meter below the surface. So data analyzed from the northern region did show that suitable temperatures, the 20 degree threshold, was reached at the end of May and was almost consistently above that temperature until September. However, when we came to collect the logger in the south, it was missing. So we were unable to collect any data from that logger. But if we have a look at sea surface data available from the EU Marine Surface Information Platform, we can get a general comparison between the northern temperatures and the south. So when we downloaded this data, we wanted to look at the temperature around when the nest was laid. So this is data from 2018, from the beginning of May to the beginning of July. The white dot on the map is where the nest was laid. And the scale, it is the lighter orange color that we're looking at for that threshold temperature of 20 degrees centigrade. So if we look at the beginning of May, we can see that where the continental shelf is wider and you get the shallower waters, 20 degrees was reached within the northern regions. However, in the southern regions, this temperature was consistently low throughout May, and not until June, where we can see that summer has arrived, and that we get similar temperatures to the north. However, there is this band here, which where the continental shelf is at its narrowest, you do get the cooler temperatures. And this may reduce the likelihood of sea turtle activity along that specific part of the coastline. So because we lost the data for this area, it would be advisable to do further research for the potential of the marine limitations of the temperature along that part of the coastline for nesting. So overall, from our survey, we can conclude that Albania can support loggerhead nesting. It has the warm enough waters, it has the suitable characteristic for the beaches, and it can successfully incubate, has the correct incubation temperatures to support successful hatching. The nest at Divjaka, it was excavated by members from WWF Italy, and it had an 88% hatchling success rate, which is really good. So, however, with the results from phase 1, we can't confirm that the entire coastline is suitable for nesting. There are questions whether or not certain beaches will have warm enough temperatures, and in the south, where we weren't able to confirm the data for the seawater temperatures, more work needs to be done there. So that was phase 1. We're now moving on to phase 2, in which we have a workshop planned, which was supposed to be in phase 1 to present these results with the local ministries and talk about next steps. This will hopefully be happening within the next couple of months. We also want to determine how to increase monitoring and the detection of the sporadic nests along the coastline. This year, there was another nest that was confirmed by HASH at Semen, which is just south of Diviaka. But there were also social media reports just recently of hatchlings off the northern part of the Albanian coastline, meaning that there are probably nests occurring along the Albanian coastline which aren't being identified. We also want to develop site-specific conservation measures for the laid nests at specific sites, and also look at exchanges of knowledge and experience with other countries which experience sporadic nesting, like Spain and Italy. And that's it. Thank you.
Thank you very much, Vicky. We're moving to the last session, session 5, marine litter. Thomaris Lachogianni from MIOS will begin with addressing marine litter on the science, policy, society interface, advances and best practices. Thomi?
Yes, I'm here. Good afternoon to everybody. It's a pleasure to be here, and thank you very much for the wonderful opportunity to join the Z conference. I know that all of you are quite tired, and that therefore I will do my best to keep my presentation short. So let me see first to share my screen with you. Okay. Okay, share. All right. Oops. Do you see my screen?
Yes.
And the presentation?
Yes.
Okay, cool.
Please maximize it and we will...
Yeah.
Thank
I
you.
will. It should be working. Oh my God. Things are happening here. View. Okay. What is it? Slideshow, sorry. From the beginning. Okay. So the topic that I will talk about is marine litter. It is closely linked with issues related to blue governance, but also to climate change, considering that, for example, marine litter, the bulk problem of marine litter is plastic pollution, and plastic production contributes to climate change emissions. But before I go into that, just a couple of words for our organization. We're a federation of 130 Mediterranean NGOs working for environment and sustainable development. And in fact, for the past more than 15 years, we have been working on the issue of marine litter at different levels, including raising awareness, promoting co-responsibility and consensus building, building the capacities of target audiences, filling in the knowledge gaps, and also strengthening decision-making. And this is just a list of the most recent marine litter and plastic pollution projects that we have implemented, with the most important ones and closely linked to the scope of work of your projects, the Interreg-Med Act for Litter and the Interreg-Med Plastic Buses MPAs, which both projects worked to address the issue of marine litter from different perspectives in Mediterranean marine protected areas. It is an indisputable fact that marine litter is a global threat, that it's growing, and this is confirmed by a large number of research articles. Here you can see how the number of published works have increased in the last 20 years. So we started with relatively smaller amount of articles published on the issue 20 years ago, and now we have reached a number of more than 1,000 articles, research articles focusing on the topic of marine litter. And the topic emerged to a large extent also from the concerns that were expressed and the momentum that was created bottom-up from the people. Something that has been confirmed by a large-scale study that was carried out within an FP7 project that we were involved. And the citizens attributed the root cause of the problem to the product and packaging design and the behavior rather than the lack of facilities or accidental loss of items, which is quite important in terms of solutions. On the other hand, at European level, there has been a large number of projects, research projects focusing on the issue. And here you can have an idea of the focus of this project. So almost about half of the projects are focusing on monitoring and explicitly on monitoring and assessment aspects, because marine litter is one of the descriptors of the Marine Strategy Frame Directive. And during the initial assessment that was made by the member states, the majority of the member states highlighted the need for data. There was lack of data and the need for harmonized marine litter monitoring approaches. With regard to the management cycle of marine litter, here you can see the different, let's say, steps. So the detection of the problem, the understanding of the problem, all the way down to selecting the appropriate solutions and putting them into action. And I would say that at this stage in time, we are more at the stage of understanding better the problem, even though there are still some unknowns. And we have already identified some possible solutions, and nowadays some of these solutions are being piloted. I would like also to emphasize on the knowns and unknowns and the certainties and uncertainties regarding the issue that provides the solid foundation towards undertaking action. So first of all, one of the knowns is that the majority of the litter originates from land-based sources rather than sea-based sources. At least this is in the case of the majority of the areas, but this doesn't mean that in some areas sea-based sources couldn't play a more important role. And this is, for example, the case in the Northeast Atlantic, where the majority of litter item originates from sea-based sources. Then also the relative importance of the sources is very difficult to establish, given that it's a considerable amount of litter could be attributed to sea-based and land-based sources. Then a lot of studies are biased towards reflecting the inputs of tourism with regard to marine litter, simply because they're being carried out in touristic locations, and obviously they reflect the problem that is being created by touristic and recreational activities. Then another main uncertainty, let's put it like that, is the so-called transboundary effect, which is quite difficult to be determined. And there are several studies modeling the circulation of marine litter. However, the majority of these studies are considering litter as a two-dimensional item, which is not the case in reality. And also the riverine inputs of marine litter are substantial. In respect to the composition of litter, the majority of it is made of plastics, and that is why we're talking about plastic pollution. In the Mediterranean, a large amount of items is made of single-use plastic items, and not just in the Mediterranean, but in the European regional seas, meaning that, and this is actually how the single-use plastics items directive emerged. But one underestimated aspect of litter are fishing and aquaculture related items, which, for example, in some areas of Greece, including protected areas, account for 37.5% of the total items recorded, meaning that the measures in these areas should focus in managing better fisheries and aquaculture plants. In respect to the microplastic quantities that are entering the marine environment, there are no reliable estimates. This is a research field that is still largely expanding. And also what we do know is that even if releases of plastics to the environment would cease immediately, the number of microplastics in the ocean due to the fragmentation processes would continue to rise. Now, when it comes to the litter impacts, there are still uncertainties regarding the extent of harm that is being caused to marine species by ingestion of microplastics, and also to the exposure potentially caused by these organisms to hazardous chemicals that are theoretically leaching from or are being absorbed on microplastics. And actually, these certainties or uncertainties have been very interestingly mapped by a recent report published by SAPEA on microplastics in nature and society. So these are not my personal conclusions, but these are the conclusions that have been drawn by a large number of experts in the field of microplastics. Currently, there is no evidence to support or refute potential biomagnification of particles or associated chemicals. The basic toxicological data on the consumption of micro and nanoplastics by humans for a food risk safety assessment are lacking. And last but not least, the measurement of the full economic cost of marine litter, including the inhibition of the proper functioning of marine ecosystems, is not possible. And when it comes to measures, what we do know is that, for example, substituting conventional plastics with bio-based plastics is merely a distraction to the marine litter issue, because simply we are changing the source of the material for the production of the plastics, but at the end of the day, those bio-based plastics pollute in the same way the marine environment. And when it comes to replacing everything with biodegradable or compostable plastics, this should be done in the case that we have the necessary conditions for treating this kind of plastics. Otherwise, if they're just collected together with all the conventional plastics, they're causing an additional problem. And then also end-of-pipe solutions such as cleanup operations cannot address the issue. They're just a small part of the solution. One of the speakers early in the morning introduced the MSFD, and marine litter is one of the descriptors of the MSFD. And actually, the countries at this stage have drawn their monitoring programs, and they have reported on the programs of measures. And nowadays they're working on baseline and threshold values. And this task is being supported by a technical group, which I'm a member of. And actually one of the most recent advances that have been made in the field is that all member states have agreed on a threshold value for beach litter. And this is the number of 20 items of litter per 100 meter stretch. So this is what the member states should reach in order to achieve good environmental status. And this is going to be quite challenging, considering that during the baseline marine litter assessment for all European regional seas, some of the member states had a baseline value of marine litter more than 1,000 or 2,000 items. So that means that basically the MSFD cycle has to be repeated several times before they are able to reach good environmental status for this descriptor. I don't know how many of you are aware, but because of the issue of marine litter, a European plastic strategy has been adopted at European level, and a lot of investment is being basically driven by this strategy. And actually last year we were in a fortunate position to see also the single-use plastics directive being adopted, that one of the major elements of this legislative piece is that it introduces bans for certain plastic items, for example. At the Mediterranean level, we have the regional and the Barcelona Convention level, we have the regional plan for marine litter management, which has similar objectives, I would say, with the plastic strategy, is a softer, let's say, governance tool. Nevertheless, all contracting parties of the Barcelona Convention have been focusing a lot of actions towards dealing with the issue of marine litter, either in terms of monitoring and enhancing the knowledge base or in terms of piloting measures. And these are the kind of measures that have been agreed and have been piloted. So there are several studies in the last, let's say, 5 years emerging on the topic. And we ourselves carried a large-scale study with other NGOs as a participatory science experiment in order to produce fit-for-purpose data to support the MSFT. And this was actually being done by using the agreed or the provided monitoring protocol from the MSFT technical group on marine litter. And actually our findings, these are the locations where the study took place, and some of the findings include that 90% of the litter items were made of plastics, almost 40% was made of single-use plastics, and on the left bottom side of the slide you can see also which items were the top 10 items. Which actually reflect the typology of the beaches, which were mainly touristic beaches. But as you can see at the beach level, the portion of single-use plastics items fluctuates, it differs depending on the specificities of the different beaches. And this was also the case for beach litter surveys that we carried out within the InterregNet Act for Litter project that was carried out explicitly in marine protected areas. And actually, to our knowledge, this was the first sort of study that focused on assessing in a harmonized way and following the MSFT protocol to assess beach litter in marine protected areas. These are just some facts and figures in respect to the socioeconomic implications of marine litter, considering that we're talking about blue governance, and marine litter really costs in the different sectors, whether these are vessels, whether these are aquaculture plants, or ports and marinas, or municipalities. And just to highlight that this number reflects the direct costs that are being caused by marine litter primarily, and in some cases indirect costs. However, the inhibition of the ecosystem services, for example, and the implications that would have for the sectors was not possible to be assessed. This is just a list of the main projects that are dealing with the issue of marine litter. And here I would like to stress mainly the Act for Litter, the Amare, the Med Sea Litter, the Med Blue Islands, and also the Plastic Busters project, because they focus on assessing marine litter in marine protected areas. But I will just put some emphasis on the Plastic Busters MPAs, because this is a project that we are involved of. We were in charge of the studying component, which was all about identifying and defining harmonized monitoring and assessment methods for marine litter in all environmental matrices, including biota. The project in general has several activities. So one of the activities was dealing with the harmonized monitoring approaches, and I will come to that in a few seconds. Then using these harmonized approaches to diagnose the impacts in endangered species, including marine turtles. Another major activity is dealing with identifying marine litter hotspots in marine protected areas in the Mediterranean, building the capacities and transferring knowledge in managers of marine protected areas. And all this information that will be obtained eventually will be will form the foundation for setting up a joint governance plan. And one other important activity is showcasing prevention and mitigation measures that could be implemented at MPA level. And this is yet again another activity that MIO is leading. So that let's say the added value of this project is A, that is focusing on marine protected areas, and B, that it's focusing on endangered species, and C, that is trying not just to confirm the presence of litter in endangered species, but also to go one step beyond and try and assess the actual impact in the health status of these species, including marine turtles. when it comes to the different measures that are being at this very moment piloted, these include measures that try to develop or to set up single-use plastics-free beach bars, or in some countries. I forgot to mention that in the project, several countries participate, including Greece, including Albania, Croatia, France, Italy, Spain. And these measures are being piloted in those different countries. So another measure is the Adopt a Peace scheme, which is mainly for raising community awareness and ensure community engagement into taking up collective action to address the problem. Then other measures focus on establishing the derelict fishing gear management scheme and promoting co-responsibility, specifically trying to tackle fisheries and aquaculture related litter. Then another measure is dealing with cigarette butts, which are quite an issue in several protected areas, as also in Zakynthos, for example, MPA. Then developing a network of collection points for beverage containers made of PET, aluminum, or glass, setting up a reusable cup distribution system for beach bar and festivals, considering that a lot of this kind of activities are taking place on the coastline, and also dealing with polystyrene fish boxes, which in some marine protected areas that are located in the vicinity of fisheries grounds or aquaculture plants is a major issue. So these are more or less the measures that are being piloted in the project. And I would like also to emphasize that one of the, let's say, major challenges when it comes to not just dealing with marine litter, but in general, is trying to turn science and all these scientific data collected into policy and actions, because to a large extent, these projects are there in order to strengthen the science policy society interface. And then, so when it comes to the marine litter issue, for example, the large amount of single-use plastics found on beaches underlines the urgency of implementing targeted measures to address them effectively. And in this context, we have high expectations that the single-use plastics directive is going to have a big impact. Then reversing the cycle of decline of the coastal and marine environment requires a paradigm shift in our lifestyles and also in the way we think and act. And herewith, I would like also to stress that it's not just a consumer issue, but it's also a production issue. And having said that, marine litter is an example of a problem that does not have a solution that fits all, but it requires a combination of multi-stakeholder and multi-sectorial efforts across nations and disciplines in order to address it effectively. And with that, I would like to close my presentation and thank you for your attention.
Thank you very much, Tommy. Very important actions, the one that you participate in. Moving on to Laura Bray. Yeah, can you hear me?
Yes, yes.
Oh, okay. Tommy, probably you have a problem. Moving on to Laura Bray from the Hellenic Center for Marine Research. She will present the ingestion of marine litter by loggerhead turtles in Greece. Laura, please.
Yeah, just share the screen. Okay. Hi there, good afternoon. I'm just going to quickly run through some of the some recent results that we found regarding the loggerhead turtles in Greece and the ingestion of marine litter in a recent research program that we coordinated here in HCMR. One of the main points of marine litter is how it's associated with the blue growth. So looking at how in terms of we can sustainably increase the coastal tourism in regions without having this kind of cyclic impact on marine litter. So we have impacts of marine litter where we have a decrease in the interest of coastal tourism, that tourists are less likely to enjoy coastal regions which have high levels of marine litter. We also have the opposite, the flip side of this, where coastal regions high levels of tourism creates a lot of single-use plastic, as was mentioned in the previous presentation. So one of the important ways to address this is to try and look at how this level of marine litter impacts the biodiversity of a region. And loggerhead turtles are an important indicator species in this. The last few months, the Hellenic Centre for Marine Research has been trying to propose Caretta caretta as an indicator turtle for the Marine Strategy Framework Director. So as an indicator species, using this to measure thresholds of marine litter in the regions. It's been proposed as a species, but it's not currently been accepted yet. In many, looking at marine litter, the plastics, as was mentioned before, is the main problem that we find in coastal regions. So this is the marine plastics are universally found. They are typically very resilient, quite difficult to break down, and that we find them in all coastal zones, from offshore to coastal regions, but typically in areas where we have high levels of tourism and coastal use. So Caretta caretta is an important indicator species in this sense, in that we often find that species have ingested plastic, which is quite well known recently, especially macroplastics. So these are plastic sizes which are larger than 25 millimeters. And this is the kind of plastics that are a major problem in coastal regions. So we do have the issue of microplastics, which are the very small particles, which are not quite so socially, people are not quite so aware of the impacts of microplastics, but it's quite clear, and it's quite associated with this idea of blue growth and coastal tourism. It's quite obvious that the impact that macroplastics have on our beaches. So it's useful that Caretta is typically a large species. The adults can reach up to 100 kilograms, and that they're able to ingest large pieces of plastic. And it's common that we find pieces of discarded fishing gear, plastic bags, pieces of plastic bottles within the intestines, within the guts of sea turtles, which have washed up ashore when they've been found dead around the coastal zone. So it's also very useful to be able to assess on a large spatial scale. So as was mentioned on the previous presentation, that sea turtles are migratory species, so we can use this to assess at a very large scale, at least at a level of a country, but more importantly within a region. So it's how we can push the policy ideas of reducing marine plastics to a regional level, because it's not enough one country or one region just reducing the amount of single-use plastic for the sea. It's important for it to be a holistic approach. The problem is that we have quite limited information about the impacts of these macroplastics and microplastics and to the health of the sea turtles. So here I've got on the screen we discovered a large Caretta species about 2 years ago, which had ingested 3 large items of macroplastics. But when you look at the length of the intestine and the stomach of this 75 kilogram Caretta, it was a 6 meter long intestine. So the question is then, how much do these pieces of macroplastics actually influence the sea turtle? In very few cases, you can see that there is, especially in smaller individuals, you can see that the plastic was actually the cause of death, but in very few cases. So it's quite, and a lot of, as the previous presentation mentioned, the focus on recently is on how we can assess the impact to the health of these turtles. So maybe the ingestion of the plastic affects their feeding habits. Maybe there's leaching of the chemicals of the plastics into the tissues of the organism, which affects it on a very small scale level. And this is kind of the information that's not known yet, and this is why it's only been proposed as an indicator species in terms of monitoring the levels of plastic so far. So it's an important gap in our knowledge base. So just to talk quickly about what we found in Greek turtles. For a period of over 2 years, we analysed 49 turtles. There were 49 strandings which we were able to analyse, which is not actually that many when you compare the number of strandings per year, which are in the hundreds in Greece. This is very related to how well you can coordinate in different regions of an area, how well you can coordinate your the vets that will perform the necropsies, and being able to transfer that to laboratories, which then can make analysis of the plastics which are found in it. So it's quite a limited number of the total number of strandings. And that's something that we found in the project, in the Indesit project and the Plastic Busters project that we're operating under. It's how important is the network of stakeholders, of local people on the ground, being able to communicate when turtles are found, when they're stranded, and being able to send the stomach contents to our workshops. As you can see, we had quite a good distribution around the Greek seas, with a lot of a focus near highly popularized areas. So areas where people were using beaches more often, there are typically areas where people found stranded turtles. So it's not necessarily an overlap of where turtles are found, it's more necessarily of where turtles were found in close proximity to urbanized areas. Typically we found that on average, most turtles had ingested plastics, and the average number was around eight pieces of plastic per turtle. But there was a huge range between the large differences between the age groups of the turtles that we found. So in terms of early stage and late stage juveniles, there was a huge difference in the number of so the smaller juveniles had ingested around 25, on average 25 pieces of plastic, in comparison to around 3 or 4 pieces for later stage turtles, which was even decreased even more to the larger adults. So we're talking about quite low numbers of plastics in terms of the kind of the intestine lengths that the turtles have. This is it's quite different to the results which were found in Italy. So within the same project, the Indesit project, we had many different partner countries, and Italy they had a lot higher numbers of plastics. And it's a question that we haven't really understood. Why is it because the Greek turtles eat less plastic? It seems quite. It's also another area of research that we've not found many answers to, as to why we have such low numbers of plastic ingestion. Most have ingested plastic, but just not high numbers of it. The most common types of plastics were the polypropylene and polyethylene plastics, which kind of the polypropylene is the higher density kind of, which are used for containers, and polyethylene was more commonly used for plastic bags. So these are all items which were commonly found in coastal zones, especially during tourist periods, of single-use plastic bottles and caps and bags. The majority of these items were macroplastics, so 53% of the items were larger than 25 millimeters in size. We did also find around 20% of that being microplastics, and around 30% being in this kind of mesoplastics, which are kind of the in-between size. It's quite difficult to use Caretta turtles as an indicator for these smaller types of plastics, because it's not very clear the connection between the large items and the smaller. So if you find a smaller piece of plastic within the turtle, whether this is a small fragment of a larger piece that was broken up during the process of ingestion, or whether it was actually ingested as a microplastic size. So that's also it's why it's quite important to have a multiple range of bioindicator species for monitoring the levels of plastic. So usually it's much more appropriate to monitor fish species for the ingestion of microplastics. It's obviously fish find it very difficult to ingest larger plastic sizes. So this is just a brief overview. I just wanted to highlight how important it is for the future to increase the number of samples that we have. 49 turtles it's okay, but it's not that many. And it's very important that we do increase this. So maybe the differences between countries are based on the low levels of statistical significance due to our sample size. One of the main point is to be able to increase the knowledge that we have in terms of how these items affect the health of the species. So whether they affect the feeding or the mating or the migration of the species is a huge topic which we're not anywhere near being able to address yet. And then finally, I just wanted to highlight how within all of this approach, how important it is to be able to maintain and increase the rescue and recovery network that each country has. So that's this is often forgotten about during larger project proposals, is how we can continue to support, mostly financially, the regional networks which are mostly NGOs or individuals which assist in this very important link between identifying samples and being able to analyze them in the laboratory. Okay, this was just a very quick overview, but if anyone has any questions, then please send me.
Thank you very much, Laura. Yes, we have a question. Is there any difference in plastic injection between benthic and oceanic feeders that could maybe explain the difference with the Italian turtles? Maybe they mostly feed pelagically there.
Yeah, so it's true that there was a big difference between the so the smaller turtles, the benthic feeders, have ingested a higher proportion of high density plastics. So we do see a difference in the type of plastics that they find, and that's probably maybe this is also correct, that it's to do with the age stage that the turtles are found at as to the number of plastics. So maybe there's a difference into the average age of the Italian and the average age of the Greek. This is very true.
And another one, are there any efforts done to address sampling biases, since only dead turtles are examined and thus probably with higher probability to have ingest plastic?
Yeah, this is a good question, but it's also very, it's quite controversial. It's true, there's no way that you can avoid this because obviously they're a protected species, the turtles. I think one of we measure many parameters when we assess the turtles that were found. So we assess the health status in terms of how fat they are, basically, to see how healthy they were, the size, the area that they're found. I think that it's if you find turtles which have a very low health status, which have very low levels of fat. This is obviously a very biased statistic that you found plastic. It's kind of logical. So in some of the analysis that we run, we do remove certain categories of turtles. Yes, but this is also it's quite important for this reason to increase the number of samples that we have to be able to reduce this bias.
Yes, thank you very much. We're moving on to a presentation that was supposed to be in session three, marine policy, but we will do it now. It's from Pierre Vigne from the MedPan network towards transboundary monitoring and conservation of mobile species within the MedPan network.
Hello, everyone.
Hi.
As I told you, Stelios, I'm not very confident with the quality of my internet connection, so I will let you share your screen.
Yes.
And follow, I want to also, of course, thank you to provide us with the opportunity to share on our work here. MedPan is not a partner of the BlueCoast project. However, there is here, of course, at least two connections. One is that the National Marine Park of Zakynthos is one of the subsidiary of the project and is also one of the founding members of our network. And also that, and this will be the point here in this presentation that I will share with you on activities that we carry out within the network to foster transboundary cooperation for mobile species and in particular marine turtles monitoring and conservation. So you may not all know what is MedPan, but MedPan is the Mediterranean network of MPA managers. So here on this first slide that I will not comment too much, you have like, there's like a number of very familiar faces who have been, well, MPA managers and practitioners involved over the last 10 years and still currently involved in the activities of our network. So we can, of course, move to the next slide. Here. So here is to, well, first give you a very quick insight on what is MedPan. MedPan to date is like composed of 128 organizations. It's almost just as good as MIO-CSDE. Either they are partners or members of the network. What is important to mention here is all the members of MedPan are MPA management bodies. And then besides the members, we have partners that can be either institutions or regional NGOs or field NGOs involved in the field with MPAs. Altogether, there are around like, well, in 21 countries around the Mediterranean basin, representing a little more than 110 managed MPAs. So if we go to the next slide, this slide is mainly to show you what is the complex overlap of statuses and designation of what we call MPAs. This is a map that is taken from the GIS database, MapAmed, that MedPan together with our colleagues from the SPARAC are maintaining and updating every 4 years. It will be actually updated this year. What you have here on the screen is not the last update, but it's just to show you, and I will not comment much more, that when we talk about MPAs, it includes national designations such as national parks, nature reserves, as you will find them all around the Mediterranean, different countries, but also Natura 2000 sites, the Pelagos sanctuary that by itself is like almost 90,000 square kilometers, represents almost half of the surface coverage of the MPAs around the Med, and many other designations that you can find on this map. If we go to the next slide, because I will try, of course, to be short. I know that I am the last speaker here. I would just like to tell you that MedPan is working on 4 different pillars. Our work is mainly about knowledge. So as I already mentioned this GIS database that we are maintaining. And every 4 years also, we are updating what we call the status of Mediterranean MPAs, which consists in analyzing the results of a large, extensive questionnaire that is circulated to all the MPAs in the Mediterranean, and from which we take stock on the status of the MPAs, their situations in terms of management, resources, etc. A big part of our activity is about capacity building, which consists in a range of tools that go from experience sharing workshops, smaller exchange technical events, producing guidelines, etc. We're also here, of course, in all the possible conventions you could think of to advocate and be the voice of the MPAs at the EU and international level. And we also act as a science policy management interface, and this is particularly what we are doing, triggering an extensive consultation process every 4 years, which we call the MedMPA Forum and Roadmap process. And well, it is this year again to update a roadmap that is defining the steps that MPA should take to achieve their targets. So of course, for reasons we all know, this consultation process that we start next week will be fully online this year. If we go to the next slide, the slide is to mention that, of course, MedPan is working on topics that are topics of interest for MPA managers, among which you will see that one of the topics we are more particularly working on over the current period and for a few years now is mobile species. But we can move on, and then I will go straight to the point. If we go to the next slide. Here on the next slide is more, so to remind that, of course, MPAs and MPA networks, among other tools and approaches, of course, can contribute effectively to the conservation of mobile species in general and marine turtles in particular, as long as, of course, they are designed over portions of habitats that are important for the species and can be managed. So as a second point, we want to remind something that could sound obvious, but that, yes, when talking about highly migrating species that are moving species, knowing no borders, these species are committing the MPA managers to what we often call this ecological solidarity and to collaborations beyond their local level, which like concretely means that this cooperation is to ensure that conservation efforts that will be made on nesting sites in Greece, in Zakynthos, for example, should not be lost in the Adriatic somewhere in bycatch. So as much as possible, we are trying to foster this transboundary cooperation to ensure that the effort that is put on conservation is well disseminated and that it is also based on this ecological solidarity. And as a third point here is to mention that, of course, we believe that cooperation, transboundary cooperation, cooperating beyond borders, is an added value on many subjects. You could take almost any topic, management topic, it could be true. But of course, as a matter of fact, for the reasons that I said just before, mobile species are explicitly emphasizing, showing this added value. And for this reason, as a network, we believe working on mobile species is very interesting because they are a vehicle that is raising the awareness of the MPAs on the need they have to work together actively beyond their local, beyond the local level and at Mediterranean level. So if we go to the next slide, here we are, as I told you, currently updating the status of Mediterranean MPAs. This new version of the status will be available by the end of the year. So here, what I'm showing you on the map that is not very visible probably from your screen are just some preliminary results that we got out of the 276 responses we received to this big questionnaire, which is a very good sample because it gives a very good representation of the situation around the Mediterranean, knowing that the 3/4 of the responses we got are from national designated MPAs, which are usually those that are the best managed MPAs. So this map is just, and you will find in the new version of the status these results showing here for turtles what are within these MPAs, key areas, those where monitoring activities are being carried out, those where conservation measures are being applied, and those, of course, that were designated for the conservation of marine turtles. So here is to say that like for a few years now, actually since 2017, not 2018, we have been developing and supporting many activities that are bringing together, of course, the MPAs, but also all the related NGOs and partners, researchers also, that are working on mobile species to implement an integrated management strategy for these species and acting at the different levels where this strategy needs to be integrated. If we go to the next slide, I will get more particularly into, these 3 next slides, and I will be very brief on this, is to mention that we have currently 3 big projects that are providing a framework for us to implement these network activities. So one of them that you must know already is the MAVA Regional Coordinated project for the conservation of sea turtles in the Med. We are one of the partners among others with these activities that are focused on increasing knowledge, securing long-term buy-in for sea turtle conservation and scaling up site protection. Another project on the next slide that I want to mention is the Interreg Med MPA networks. We are leading this project together with 9 partners that for most of them are MPAs, and for 2 of them are an NGO in Albania, the INCA, that is working in Karaburun in Sazan, MPA, and the Mariles Foundation that is working with MPAs in the Balearic Islands. So the point in this project stands in the name of the project, MPA Networks. It's working on networks, activating new network at national level in particular, network of MPAs, working on connecting these networks together to help them support effectively managed MPAs. And here we are focusing on several topics that are the topics that are priority topics within the management plans of the partner MPAs, and one of them is mobile species conservation. And among the 3 partners that are implementing pilot activities on mobile species, one of them is more particularly working on turtles, and this is Zakynthos National Marine Park. And I will also mention on the next slide, the Cogito project. That is a project funded by the French Global Environment Facility, and that is a project that is to enhance integrated and sustainable management of coastal, insular, and marine protected areas in the Mediterranean. But now we'll get straight into providing you this quick overview on the activities we are carrying out. We had last year our regional experience sharing workshop, as we have every year. That was in Turkey last year, in November last year, on managing highly mobile species across Mediterranean MPAs. So here on this slide is to remind that we are also migratory and highly mobile species with a sadly big environmental footprint. Well, not this year, but we had last year. We had 140 participants coming from 23 countries. So I think that, Stelios, if you press, you will, yes, it is to say that the overall purpose of these regional experience workshops is to allow the MPA managers, but also all the related stakeholders that are concerned with the topic, to pool and share information, expertise, to take stock on the current challenges here for the conservation of the highly mobile species. And of course, it is also about meeting, discovering, inspiring each other, building cooperation, long-term approaches together to implement solutions, with as unexpected outcomes, targeted recommendations that were put together within the proceedings of this workshop. On the next slide, I will just share with you, because this workshop, we decided in the approach not to have sessions on marine turtles here, monk seals here, cetacean here, but to have sessions that were mainly to tackle cross-cutting topics for highly mobile species on knowledge, awareness raising, regulatory frameworks and enforcement, conservation measures, network and collaborations, which are all key topics for an integrated species and habitat approach to address the issues of all these species. And we found very interesting to have this approach, finding out what the monk seal has to say to the turtles, the seabirds, to the cetacean, and to run this workshop in this way. On the next slide, I will just share with you maybe some interesting results that we got when we circulated before the workshop a short questionnaire together with a call for communications among the MPAs of the network and beyond the network to collect case studies proposals. So here you will see that case studies that were targeting to marine turtles came in the first position before other species groups. 61% of the respondents had case studies that had to do with marine turtles. In the next slide, it's also some results of this short questionnaire that we circulated, because we asked several questions to the MPAs regarding the different species groups. So here again are the responses we got regarding marine turtles that can be, that you may find interesting, because they give you also, they will help you better understand what is the connection between marine turtles and MPAs so far and the situation. So 48%, almost half of the MPAs that answered this questionnaire say they are designated partly for the conservation of marine turtles. And you see that like in more cases, 57 and 54% of them, they are applying, conducting regular monitoring or applying conservation or restoration measures, which means that sometimes they are not designated for the conservation of turtles, but still they are doing something. If you go like a little more in detail in these responses, you would find out that, of course, these are mainly nesting sites that are actively involved in monitoring and applying conservation measures. It's for other MPAs, it's a little more scarce, of course. So here we got also like some data on the function of the MPA for the species, which I will not comment much more. And maybe more interesting, because this shows, if you click Stelios, you will see that we also asked the perception of the MPA managers on the main pressures that are affecting the species. And here, probably it will not be any kind of surprise for turtle specialists to see that fisheries come first as a high pressure on marine turtles in MPAs, followed by pollution and marine litter that was still considered by like a third of the respondents as a high pressure and another third as a medium pressure. Boating and maritime transport are also considered as a significant pressure. And Stelios, if you click, you will see that another like 3 pressures that were mentioned: land-based tourism, noise pollution. And since here you are talking on climate change, it is very interesting to see that still, when talking about climate change as a pressure, 53% of the MPAs just do not know. And this is something and a result that is very consistent from other results we get whenever asking MPAs about climate change, that they have as a perception that climate change is a big issue, a huge issue, but that they still do not know. So this is, of course, a message to our colleagues from the MPA Adapt project. Joachim was like talking earlier that there is a lot to do for getting MPAs to work on indicators and strategies of adaptation of their management plans in relation to climate change. If we go to the next slide, yes, you will find the recommendations of this workshop if you are interested on the MedPan website. I think there is a little image if you click again, Stelios, of the proceedings that are available from our website. But we produce recommendations that are focused on targeted measures for MPAs, on the contribution of MPA at the broader Mediterranean scale, on existing initiative and what can practically be done in line with these initiatives, fostering monitoring and management network-based approaches, which is, of course, as an introduction, I said, an important issue for us as a network and for the conservation of the species. And highly mobile species as an effective way of motivating stakeholders' engagement as flagship species, of course. And also part of the workshop was about working on identifying gaps and needs at the national and regional level for identifying important areas. On the next slide, we also, part of our strategy was to set up in 2017 a dedicated group of MPA managers, not only, but composed in a majority of MPA managers working on marine turtles, with as an objective to support and sustain knowledge sharing and collaborations over time. So as I said, the group is mainly composed, there are several groups working on marine turtles around the Mediterranean, but the group that we decided to set up is mainly composed of MPAs, because here what we want is to really get the group in its work and contribution to answer and provide inputs and guidance in line with MPA needs whenever they are working on marine turtle conservation. So as a general aim of this group is about building trust and foster collaboration among first the member of the group and among the wider med community to increase the capacity for the conservation of the marine turtles. Here, I just want to, because build trust could sound like, what is this, building trust? But yes, we found from the beginning, experiencing activities within this group, how important it is to build trust at the scale of a little group to then hopefully be able to disseminate cooperation on a larger scale. And I'm mentioning this because one of the discussion we had recurrently within this group is about cooperation between MPAs and research institutes or field NGOs, and about data sharing and all the things that you know can be sometimes a big subject of discussion. So here it's just to recall how much important it is for the MPAs that all the NGOs and research institutes working with them in the field and helping them a lot, collecting data, monitoring every day, or sharing timely the data, at least those that are important for management purpose. But we can go, of course, to the next slide. That is to say that the group so far is meeting once every year. Met in Zakynthos, Torre Guacheto, and Cyprus over the last 3 years. For reasons we all know, we could not meet this year, but we will next year. And for now, we are having online exchanges. And as main achievement of this group worked on setting a cooperation framework, trying to set the conditions for data sharing in particular, and also advised for the development of a guide for marine turtles monitoring in MPAs that will be available this year in October. It's in the finalization layout phase. The group also contributed to the reflection on the important marine turtles areas criteria, and has also been providing inputs for selection of projects we are supporting through our small grant scheme that were project on marine turtles. I will just on the next slide actually mention these projects that we are supporting over this period, like between 2019 and until next year. We had like 5 of them, 2 of them, one in the Pelagie Island and one in Parliament Island Nature Reserve in Lebanon are completed. And we have 3 ongoing projects that are conducted in MPAs working on marine turtle conservation in Farwa in Libya, in Western Mediterranean MPAs in Spain, and in Cephalonia Island in Greece. And I will finish just mentioning another big axis of our activities. We are in the process of, we are setting up now a regular training program for marine protected areas. So this is an important aspect of our activity because training was really the missing link in the range of tools we have in capacity building. We had mainly tools that were focusing on sharing experience. And here, the MPAs were recurrently asking over the years that we also develop trainings in the sense of, in a more operational prospect, of training, answering MPA needs and providing them with skills that they can implement in the short term. So we we are in the process of developing a training catalog that will be implemented through 4 training centers around the Mediterranean, and a 5th one that is not mentioned here that will be in the Kouriat Island in Tunisia from next year or the year. So among these training centers, you see that Zakynthos National Marine Park is one of them. And as you guess, since we have several thematics of training, fisheries, financing, cetacean, and marine turtle, Zakynthos Marine National Park will be hosting the trainings on marine turtles. So we are, and that is will be my last slide. Currently, we are developing 2 training modules that will be implemented this year, hopefully, and next year by MedPan together with Zakynthos National Marine Park. The first training module that is currently under development with Alan Rees is focusing on the conservation of marine turtles at sea. And we started with this one knowing that as was said by Antonis Mazaris, I think this morning, of course, MPAs are already, for those that are nesting sites, aware of conservation measures and monitoring they can apply on their sites. When it comes to managing and protecting at sea, measures are really scarce. And data actually are very scarce. So we felt it was very important that we address the conservation issues at sea and of course also on nesting sites, which will be the focus of a second module that will be developed and implementing next year. And just to mention, because that we received in response to the call for expression of interest that we circulated, 90 applications, which is a lot, and which shows that these trainings are need to be repeated over time on a regular basis, and which is also our intention to try as best as we can to build the capacity of MPAs and also not only MPAs, NGOs that are involved with MPAs in monitoring and conservation activities over time. But that will be it for me, and I thank you for your attention.
Thank you very much, Pierre. This concludes the presentation, and now I will give the floor to Haris to coordinate the discussion.
Hello again, everybody. I want to thank all the invited speakers for their valuable contributions to the thematic area that more or less the BlueCoast project is dealing with, and this conference was organized as an activity, as an action of the BlueCoast project. So now it's time to interact, and now it's time to discuss, and now it's time to it's time for questions, and maybe it's time for some perceptions. So I will give the floor now to whoever wants to talk about something on, but before that, I would like to set some rules for a fruitful and productive discussion. So please respect your speakers and don't talk upon each other. And please state your name before talking, so everybody can hear who you are, and please keep short and polite. So anyone that wants to state something or ask something, or... don't forget to open your microphone if you want to speak.
Hi, can I speak?
Yes, please.
It's Kostas Kaloudis from Corfu. I'm the director of the Ionian Environment Foundation, a new organization for the environment of the Ionian Islands. I was very glad to follow this conference. I found it very useful and I learned a lot already. So I'm very thankful to the organizers and all the participants for that. I have a remark because I'm not sure how to turn these thoughts into a question, but what already triggered me when I read the title of the conference is the emphasis on the mention of blue growth, which is of course understandable because these are EU strategies that use this term. But many speakers recognize that growth is important and that it is happening, and that blue growth is happening. However, they also recognize many of the conflicts and I want to share a concern I have that speaking at least for the Ionian Sea, and I'm sure the Adriatic is the same, there is already a lot of activity along the coast, and as we saw in some presentations, there is also intense traffic in some routes. So I am quite concerned as for how more growth will be sustainable for the biodiversity. And this I do not limit to the sea turtles necessarily. But we know that we have big conservation issues already. We are a very touristic part of the Mediterranean. We are aware of existing conflicts and how it is hard to manage those. So I'm a bit concerned that more growth before we're able to manage the existing conflicts and problems will just make the situation less manageable. So I'm not sure who to address this to or who could answer something. So I leave it for everyone. That was the main point.
Thank you, Kostas, for for sharing your concerns, and I do believe that many people here are also in the same page. So, if you want somebody to comment or add something, please take the floor.
I can, if you want, comment like from the, so it's Pierre for MedPan again, talking what is our perception of death from as a network of MPAs. When it comes to MPA, which we believe, of course, is one of the important tools to protect. We know that the situation we have in the Mediterranean doesn't allow us to design MPAs like would be in other parts of the world. Because of this concentration of activities that are all around the basin, we cannot sanctuarize like is done in other parts of the world. So it is true that the issue of bluegrass for us still needs to be addressed, and that's what is probably under preparation for the next period. We will see what will come out of the next CBD for the next period. That certainly we need, of course, to keep on going with multi-use MPAs and regulation tools beyond MPA borders, but we also need to push for more and larger, strongly protected areas, which can be either no fishing, no take, no go zones sometimes. And this is, of course, one we know of the objectives that will be certainly set for the next period by the CBD. We are far at the moment, because it was already one of the objectives of the previous period, from achieving this. And it's true that, like, if you look at the Aichi target that was mentioning that we should reach 10% of protection over the seas, if you take into account all the different designation and statuses that I was showing on the map, we will not be very far from this when we will update. We will be around 8%. But 8% of what? This is the question. If 8% of like MPAs that for some of them we know are only on the paper, 8% of MPA that are poorly managed. And beyond this, when you look at the figures and at what is the coverage of what we call fully and strongly protected areas, those where we really try to eliminate any big pressure, it falls down to 0.04% of the surface of our sea, which is nothing. So if we are mentioning in the next period, like very optimistic and challenging targets around 30%, I heard of like strongly protected areas. We are at the moment, and that's one big challenge, very far from this. But this is a need to go further for strongly protected areas. This is what we believe.
Thank you. And can I ask one question after that?
Yes, thank you, Pierre, for sharing your concerns. And please, Kostas, take the floor.
How easy, how feasible is it to establish protected corridors between, let's say, between some Ionian islands, between the Ionian Sea and Italy, or between the Ionian Sea and the Adriatic Sea? If some of the research that we also saw here about the sea turtles establishes that some corridors are important to protect. How long could a process be for these transboundary corridors to be established as protected, and how feasible?
Thank you, Kostas, for your question. I'll take the opportunity here because maybe you joined the conference a little bit later than the early morning presentations. So there was a presentation from Antonis Mazaris from the Aristotle University that he talked about that at the end of the day, there is an ongoing process about establishing important areas, marine areas for sea turtles, as an analogous to the ones that are established for cetaceans. So we have a long way to go as a unified framework that it's quite adopted at the UNEP level, but still there is a long way to go just to have them on a directive or at a national level or a regulation or something. For the time being, we have to keep with the Natura 2000 network and as a protection, conservation and management scene, as well as the marine protected areas that are outside of this network. So yes, in my point of view, I think that there is a long way to go to cross, but hopefully one day we will get there.
Thank you.
So anyone else, please feel free to share your opinion and your thoughts. Okay, so since we are half an hour late to close the conference, I would like to thank you all for participating and for being members of these activities. And now, Stelios, I think it's the time to close this conference. I hope that you enjoy it and it was a good opportunity to stress up a few things, and now maybe it's time for less talking and more doing. Okay, Stelios?
Okay, so on behalf of the organizing team, I would like to thank all of you, the participants and the speakers. And hopefully the next time will not be in our screens, but live. Thank you. Good night to everyone.